Sound check. Can you hear me?
Yeah.
Yeah, it's better, right? Okay. Just gonna put this in my pocket.
I will put this back. Or
Okay.
I'll leave it here, actually.
Yeah, sure. Oh, I lost Wi-Fi. That's not fun. I don't actually. Not yet. I figured like a cute picture would maybe ease the topic. How do you like the conference so far? Good. How was keynote? Did you like the keynote?
Worrying.
You worrying? That's the point, right?
Yeah.
Still got some minutes. A couple more minutes left. 4 more minutes. Okay. Who's here attending SCaLE for the first time? First timers. Yay! Welcome. How do you like it so far? Good. Do you think you'll come back next year? Do you think you'll come back next year?
Yeah.
Yeah?
There's so many, my friend, and I have like 3 talks that I want to show to. This is for beginners, like everything's like this.
Yeah. It's great. Yeah, they record the talks, thankfully, and even live stream it, I think. So you can go back to their the YouTube channel and watch the talks that you missed. I think it's my 3rd or 4th time attending SCaLE. First time speaking. So excited. If I can pull it. Yeah. I'm from Turkey, actually. I'm living in Santa Monica right now. What's that?
What part of Turkey?
Western Turkey. So I'm from the city called Izmir. I lived in Istanbul, yeah. It's a nice place. You were there? Yeah. How did you like it?
I love it.
Yeah. It's great. Oh yeah, touristy places. Yeah, that's nice. I I spent so many years in Turkey and I haven't been to Cappadocia. And every time I say that, people go like, "How come?" But that's the thing is, when you spend so much time, you just, I guess, don't feel like going to that touristy places. Yeah. Yeah, I mean, I moved to Santa Monica. I was so excited because, you know, the pier, the Third Street. Oh, I was gonna go there every day. I gave up like after a month. Anyway, what's that? 1 minute. All right, we're almost ready to go. Can I use these waters as well? You know, check. Can I use one of these waters for speakers? Nice. So, should I start? Okay. Hi everyone.
Hello.
Thanks for coming to my talk about pull requests today. I know there are a lot of great talks that are happening, so thanks for being here, and I hope you will find it good. My name is Kivan Yazan. I am a software engineer, and I like to contribute to open source projects with little patches every now and then. So today I'm here to share my experience and give you an introduction to the world of open source. I want to start with a show of hands, actually. Feel free to raise your hand. Feel free to don't raise your hand if you don't want to. That's perfectly fine. But how many of you know what Git is? That's great. How many of you know what a pull request is? How many of you have submitted a pull request before? Okay, so that's great. Almost everyone knows what Git and pull request is, and maybe half of the audience have submitted a pull request before. The reason I'm asking is I tried to prepare this talk as beginner-friendly as possible. So I'm hoping that if you don't know what Git is, or if you don't know what a pull request is, you'll be able to walk out by knowing about it a little. And if you already know what those are, that's still great. I hope you find this talk as a refresher, and maybe you'll find something you didn't know as well. So the slides are already available online at the address. Let's actually start by showing my first pull request, because my title was my first pull request, so that only makes sense. This was, to give a little bit of background, I was still a student at the time. I had no professional experience as a developer, so I had pretty much no confidence in contributing to an open source project. I was thinking, like, who am I to, you know, write code for a big application? And one day I realized one of the applications I was using was actually open sourced on GitHub. And while looking at the code base, not understanding anything that's happening, I realized the project was accepting translations. And my native tongue is Turkish, and the Turkish translation wasn't there. So I figured, well, this is a great chance for me to give this a try. And what I did was I just copied one of the translations. There were only a few strings anyway. I translated those into Turkish, submitted, and it got merged, thankfully. So that was a great experience for me. After that pull request was merged, I felt like a happiness that came out of nowhere because this application now has something that I put in there. And you could download the latest app, you could see the Turkish translation live. That was a great feeling. And I even got a comment back from the maintainer saying thank you. And I think that's the magical part about contributing, thanking other people for their random contributions. So there are various reasons why you would want to contribute to an open source project. And that recognition is just one of them. If you just like the feeling when you help other people, that's perfectly fine. If you just want to give back, that's perfectly fine. If you want to be recognized for your efforts, that's fine as well. But my point here is there are various reasons, and you can pick whatever you want. You can contribute to open source projects just to build your portfolio because you can't showcase your code at work. That's fine. You're doing it for reputation, that's also fine. Open source projects usually are a safe space for making mistakes. So if you make a mistake, people help you figure out what's wrong, what went wrong, with not a lot of consequences. So if you're using that open source as a space for making mistakes and learning from your mistakes, that's also fine. If you're doing it for money, that's also fine. And for example, if you're a student, have no idea about what's the latest business practices, you can find some open source projects that are following those latest tech and learn about that as well. But most of all, helping each other is a really great feeling. A burden shared is a burden halved. So here I'm going to tell a little story here about myself. I used to run regularly. And by the way, if anyone's running LA Marathon tomorrow, good luck to you. Don't forget the daylight saving thing, which apparently happens tonight. I used to run regularly, and I used to train by myself, and it got boring, so I figured I should invite some of my friends, but none of them would come run with me because they never run before. So I had to find a way to bring them to the field. I figured I had all these running shirts that are given by various marathons just sitting around, so I figured I could bribe them by offering them a free t-shirt and ask them to come run with me once. And what happened was I gave a lot of t-shirts and I gained a few running buddies. In the picture you're seeing my brother. We were running together, and I was happy to convince him to give this a try, and he really liked it, and he kept doing it by himself. So I'm doing the same thing here today. I tried it, I really liked it, I kept doing it, and I'm encouraging you to give this a try as well, and maybe do your first pull request, and maybe you'll like it, and you'll keep doing it. I don't have free t-shirts though, sorry about that. The structure of the talk will be, I will talk a little bit about basics of open source, free software, and things I learned that were not immediately obvious. I'm going to talk a little about licenses and the legal aspects, only so much that you should know before contributing. I'm not going to go into too much detail. And then I'll switch to source control. Specifically, I will talk about Git. I will start building an example while talking about Git. And then I'll switch to pull requests. I will build on the example and explain how it would look. And then we will demo the example that we built. And I will close with a few pointers for you if you want to give this a try. So kind of like find my first project. Before going further, I want to give you this disclaimer. I'm not a lawyer. This is not legal advice because we'll talk about licenses. We'll talk about some legal aspects. If you need professional help, get your help from a professional, not from me. Open source, I have a bunch of words here that I'm going to talk about. Open source, free software, I'm going to be honest, I didn't even know there were two different things. Open source and free software were in my mind always referring to the same thing. But apparently they are not actually the same thing. They're referring to slightly different things. Open source is usually identified, is usually referred to by open source initiative, and free software usually by Free Software Foundation. And there are slight differences between free software and open source. I think the biggest one is free software folks tend to focus more on the freedom aspect of the software. So they're trying to make sure that once a software is free, once a software has the liberty, it stays that way forever. And open source is a little more permissive in that aspect. There are, I think, a practical difference in terms of licenses they use, etc. But in my opinion, they're all going to the same place, only with different roads. So you may as well see those two terms used interchangeably. You can also see those two terms combined. So you can see FOSS, free open source software, and free libre open source software, just to clarify that it's not free as in no money needed. The thing I learned here is if you are going to contribute to a project that calls themselves a free software project, just call it a free software project. So whatever they're calling it, the advice I can give, call it that way. We talked a little about licenses. So Open Source Initiative and Free Software Foundation, they both have their own set of kind of rules. So Free Software Foundation has a list of 4 freedoms they list, and Open Source Initiative has 10 goals of a software, all available online. And so they both have a set of licenses that they approve. If you go to Wikipedia and search for a comparison of open source licenses, you will see a list of licenses on rows, and on columns you will see whether this is approved by Free Software Foundation, whether this is approved by Open Source Initiative, whether this is approved by Debian or Fedora. So you will see picking a license is very important if you want to identify your project as an open source project. If you, for example, pick a license that is not approved by Open Source Initiative, they don't want you to call that project an open source project. Kind of like a legal thing, but very basics, things that you should know. Just because you make your code available online, for example, you upload your code to GitHub, doesn't mean you don't have the copyright to the code. And in fact, you have the copyright, and by adding a license file to your code base, you're saying, I'm letting you use my code under these terms. So if you don't put a license, people don't know what the terms are, and that means your project is source available, which means its source is there, and you don't know what you can do with it. In fact, there are some licenses that lets you only see the code, so I think that's a separate thing, but I'm here explaining the case where you don't have a license at all. In free software, I already mentioned this, doesn't refer to no money. It refers to liberty. And so free software doesn't mean the software you can get by not paying money. In fact, you can sell free software for money. You can sell open source software for money. But the question is, why would you pay for something that you can get for free? And there are various reasons. You can pay money to get extra support. You can pay money for convenience. You can pay money for donation. And there are some companies. Now, another thing, I used to think that companies would hate open source and it's like an ongoing battle. But I found out that's no longer a hard truth. There are some companies who release some of their projects to world of open source so other people can use it. There are some companies who help open source projects out by sponsoring them. There are companies who use those open source projects and in turn give back resources to them, including money or people time. So there are some companies that are built on top of open source projects, and they can make money as well. So free software doesn't mean you can't sell it. Going back to licenses, I've also found out there are basically two groups of licenses. Of course, an oversimplification, but those groups are copyleft licenses and permissive licenses. Copyleft licenses usually associated with free software, and permissive licenses usually with open source, not true 100% of time, but usually. And copyleft license is there to make sure the software stays free going forward. So it has this additional thing that if you take a project with copyleft license, if you modify it, you can redistribute it under certain terms. So you don't get to choose, for example, you don't get to change the license. You get to change the license, but you can't change the license to a more restricted one. So for example, if you have an open source project license with a permissive license, you can modify it, build your own copy, and then just sell it without distributing the source code because you choose to. Again, talk to a professional before doing so. It's not legal advice. But some examples are copyleft licenses. The most popular one, I think, is GNU General Public License v3, and permissive has MIT and Apache 2.0 are very common. Okay. Here on, I'm going to switch topics. This was all the basics that I wanted to give about open source world. I'm going to change to source control, and specifically I'm going to talk about Git. This is an application that lets you build a software. You can use it for other purposes as well, but in this case, it's for software where you can track your changes and refer to the history of the software. There are other applications that achieve the same goal, like Apache Subversion, also known as SVN. I think it's still maintained. And another one is Concurrent Version System, CVS. I think is no longer maintained, but still used by some. So we're going to talk about Git. If you want to talk about Git, I figured these are the words that I should give. These are the words I should explain before going further. Repository, commit, and branch specifically. A repository is just a project. So what happens is, for example, you go to an online Git host like github.com. You create a new project, and you get an empty code repository. You can do the same on your local machine as well. If you open up a terminal and initialize an empty Git repository, that's your repository there. The way it tracks the changes is via commits. Commits are like checkpoints in your code repository that you can refer back in future. So building on the empty repository example, assume you want to add 2 files to your repository. You put your 2 files there, and then you build a checkpoint of those 2 files, and that's your initial commit. For example, in the future, if you change one of those files, you can still refer back to your old checkpoint and see how that file originally was. You can keep adding commits and build your tree, and that's where branches come in. By default, there's only one branch, and it's called master. So you can just keep adding to your default branch and build your tree. But if you're working with multiple people, or if you're working with on multiple features at the same time, it's usually a good idea to make use of branches. And that's just where you add a branch to your tree, and then maybe merge it back into your master branch in future. More on that later. Git works as a distributed application. So if you have 10 developers working on your project, you can have 10 of them have a copy, have a clone of your code repository in their local machines. You can have a remote optionally. This could be a remote that you are hosting yourself. It could be a remote that is hosted by GitHub or GitLab. So in the example of 10 developers having a local copies of the same repository, for example, if you are using GitHub, they could push and pull the most up-to-date state of the repository to GitHub. This is optional, meaning you don't really need an internet connection or network, anything for using Git. You can just start a Git repository from your local computer. And if you don't want to push it to a remote, you just don't push it to a remote. Okay, here's some examples on how that would work. I'm going to show commits with little circles, and I'm going to call this commit A. So this is, imagine I have an empty repository with an initial commit named A. Also imagine this is a remote, so for example, for sake of simplicity, this is a repository I started on github.com. It has one commit named A, and then one branch named master. So branches work just as labels. A branch is just a pointer to a commit. It says my master branch is pointing to this commit. And that means the head of the branch is that commit. So there's no magic in branches really. The next thing you could do is if you started your repository on github.com, for example, you can clone this repository back into your local machine by running git clone, and that would bring exactly the same copy of the repository to your local machine. Now, just to clarify, you can do it the other way around as well. So you can start your repository in your local computer and then push it back to GitHub. That works too. Or don't push it, just stay in your local. That's also possible. So assume you added one more commit, commit B, to your remote repository, and now your master is pointing to the latest commit. So github.com has the updated version, but your local is out of date. How do you fix this? Is you run git pull to pull the latest changes from remote to your local. It works the other way as well. So if your local is ahead, you can push your changes back to remote, and now they're even. So we talked about branches as well. So let's just to give a quick example of the branch. You can use one of these commands, checkout, or in newer versions of Git, switch works too. As soon as you do that, for example, I have here a feature branch now that is pointing to the exactly same comment because I haven't added there anything yet. I just checked out a new branch, so I'm pointing to the same place. Later, for example, if you add a commit to your feature branch, what happens is your feature branch moves a little ahead. And maybe later you merge it back to master. It's up to you. This image I found on Wikipedia was really helpful in summarizing what Git can do, but it has too many things for the purposes of this presentation, so I simplified it a little bit to explain what I've just talked about. We have the remote on the left and the local on the right. So we talked about pulling changes from remote to your local. We talked about pushing. But one thing to think about here is what are you pushing? So if you make a change in your working directory, if you update 2 files and you run git push, you can't expect Git to magically find out what you want to push. There's a certain process. You have to create a checkpoint. You have to create a commit in a branch, and then you can push that branch back to remote. There is this extra step called stage. And it works like this. So for example, in your working directory, you have checked out a repository, you have checked out a branch. You have changed 2 files, but you only want to commit one. The stage area helps you in this, so you only stage the changes you want to commit. So you stage the one file that you wanted to commit, and then as soon as you run the commit, it just takes the stage and makes a checkpoint. Some other commands that I frequently use, git status is super, super helpful in figuring out what you have in your working files, what you have in your stage, and what it also helps you to, it also points you to the next command you should be running. Git log lists you the list of commits you had. So, for example, if I had the feature branch checked and if I run git log, it was going to print me a DCBA. If I checked out master branch, it was going to print me CBA. This is also a useful commit, useful command. So if I make some changes in my working files, and if I run git diff, it's going to show me the difference. It's going to show me the work in progress. There is a diff -- staged as well, and that's very useful to see what's in stage. Okay. Next, we're going to talk about build on this example and talk a little about pull requests. Like I said, a pull request it's just a patch. It's a commit that you offer to someone else. The fact is, we talked about pushing your changes to your remote. But if you don't have permissions to push, if it's someone else's repository, you can't direct push. So in that case, the strategy to follow is building a patch and sending that patch as an offer. Like, would you like to merge this patch into the repository? It's called pull request. It's called merge request, and it can. GitHub and GitLab and other services have a specific UI to make this easier. Some of the projects are still accepting patches through emails, which effectively does the same thing. So, for example, the time zone database that I'm sure all of the devices in the room is using they have a GitHub repository, but they don't accept pull requests on GitHub. They accept patches through emails. So that's another thing I should have probably mentioned earlier. You should follow the project's convention. If they accept patches through emails, just read the documentation they have and follow that. The pull requests and patches usually comes with a discussion, so you get a chance to talk to the maintainers. So as a contributor, you send a patch, and maybe they will have some comments for you, they will have some feedback for you, and you will have something to say. So on the demo I'm going to do, I will use GitHub, and it'll be a little more clear, but it'll be a chance to discuss the changes. The first example I showed, my actual first pull request was a translation. And this is to say that pull request doesn't have to be a code. It doesn't have to be a new feature. It can be a bug fix. It can be a documentation improvement. It can be a fixing and documentation that went out of date. It can be documenting a feature that was not documented, but there. It can be translating, fixing a test, adding a test, removing a test that was not working. It can be adding a design, a logo, anything. So pull requests are not specific to codes. That's what I'm trying to say. And pull requests, even though the talk is about pull requests, I think I have to mention this. Pull requests are not the only way to contribute to an open source project. So the bigger open source projects get, the more help they need, I think. And they can use your help in, for example, triaging incoming bug reports. So maybe they have like 10 bug reports that come in every day. Maybe they need someone's help to figure out whether they were already reported or not. And that's not a pull request, but that's still help. So I'm trying to say, while pull requests are important, that's not the only way to contribute. And don't feel like you're not contributing if you're not submitting a pull request. Even like verifying an issue and saying like, oh, this was fixed, we can close this issue, that's a great help. So here's an example. I'm going to use two names. One is owner, to represent the owner of the repository, and one is contributor, representing the person who is trying to send a patch in. So here I have owner's repository named nameprint. It's a simple code that just prints your first name. It doesn't do too much. We're looking at the master branch of the owner's repository. And the patch contributor wants to send is, instead of printing first names, let's print full names, for whatever reason. And what it happens is, contributor, this is called fork. Contributor copies the repository under their own namespace so they can control it. We're still looking at the master branch. While you can do this on your master branch, while you can make your changes on your master branch, since we talked about feature branches, let's go ahead and check a new branch called a feature branch. This is still under contributor's namespace. And make the change, make the program so that it prints full names instead of first names. And the next step is sending the actual pull request. We're going to talk to owner and say, hey, do you want to merge my feature branch into your master branch? And send that pull request. Please merge my changes. And if it gets accepted, the owner's repository is updated with my comment. To show it in a slightly more low level, let's assume owner's repository looks like this. It has two commits named initial commit and a second commit named add print.py. And the master branch is pointing to this second commit. What I did first was I first forked the repository. So I'm going to do the same here. I'm going to fork this repository into my own account. So now I have a copy of exactly the same repository. Next thing I'm going to do, I'm going to clone this repository that now belongs, that is now my under namespace, into my local machine. So I'm cloning this repository. So I have 3 copies. Right now we have 3 copies that are even, and you can see 2 of them, for sake of this example, are on GitHub, and this is on my local machine. And as a contributor, I only have access to these 2. I don't have direct permissions on owner's repository. So the next thing I did was create a feature branch before doing my work. So I go that, I say, let's check out a new feature branch. Like I said, it's just a label, right now pointing to the same commit. Do the actual work, add the commit to the feature branch, so now my feature branch has this extra commit named use full name. This is perfect. This is done. But my remote has no idea that this change has happened. So what I'm going to do next is I'm going to push my local feature branch to my remote so that it shows up on GitHub as well. So there you go. And the next step is asking for the pull request. And specifically, I'm asking for my feature branch to be merged into their master branch. And when they do, the final original project is now printing full names instead of first names. So the demo is going to be this. I'm going to do exactly what I explained here. I'm going to start with owner creating a repository on GitHub. So first thing I'm going to show you here, is it readable from the back? Yeah. So first thing I'm going to show you here is I have created 2 GitHub accounts, conveniently named owner, and in an incognito window, contributor. So I have 2 logins. First, I'm going to click this plus button here and create a new repository named nameprint. A quick description. a quick script to print names. I'm going to let it stay public so that someone else can see it and contribute as well. I'm going to pick this, initialize this repository with a README file. A README file is just going to be a nice file that says repository name and description. And one thing that is nice is it lets me pick a license from the very beginning. So if you click Add a License, it brings you a list of licenses. And the licenses I talked about, the ones are in bold, I think, are the most popular ones. So we talked about copyleft licenses, GNU General Public License v3.0. Other licenses that are more permissive, MIT license and Apache license 2.0. Here I'm going to use MIT license just because. I click Create Repository. And that's it. So right now I have a repository under owner namespace named nameprint. It has one branch, and the branch is named master. It has one commit and two files. So it has the license file and it has the README file, and the README file is also displayed here. So if you go to this commit history, you see I only have single commit that's named initial commit. So I did this, except I don't have the second commit yet. And just for sake of demo, I'm going to add that second commit from my local machine. So what I'm going to do is I'm going to go back to code here. There is a green button that stands out that says clone or download. So I'm going to click that, and I'm going to clone this repository into my local machine. Usually you should use SSH for authentication, but for sake of making this demo simpler, I'm going to use HTTPS. Let's go back to terminal. Okay, so I have this terminal that is ready for the demo. I have two directories here, one named owner and one named contributor. The reason I did that was when I'm wearing my owner hat, I'm going to be in owner directory, so it's a little easier to follow. Right now, the owner directory has nothing in it. What I wanted to do was I wanted to clone this repository. So I copy this link, I type git clone, and the paste. See, the link has owner's namespace, so I'm cloning it from there. Enter. So it cloned. Let's do a list again. There's the directory. So I'm going to cd into, change my directory into this. So right now I'm in the nameprint. If you do a list, you see the same two files, license and readme. So they're there. And if you, in case you're wondering where the git magic is happening, if you do a ls all, you're going to see an extra directory named .git, and that's where the git keeps its magic. And I don't recommend going in there. So let's try some of the comments we talked about. Let's see what git status prints. It says you're on branch master. Your branch is up to date with origin master. Nothing to commit, working tree clean. We're on branch master, and our master is up to date with the remote master. So if you do a git log, you're going to see only one commit that is coming from owner. Now I'm going to do one trick here that you don't have to do. It's a script that runs these two commands. So I run these two so that my commits I'm going to add right now are identified as owner. So next that we're going to do is we're going to add this print.py file. So let me bring that print file to where I am right now. Let's do a list and see print.py is there. Let's look inside what's there. It's a very quick Python script that reads your full name, asks for your full name, and reads it from the standard input, and then tries to split it by spaces, and then tries to get the first thing in that list, and then prints the first name. So let's actually give that a try, see if that works. Python 3 print.py. It asks me what's my full name, and if I print my full name, it's welcoming me with my first name. So that seems to work. Okay. Now, what's the next step? Let's do a git status and see what's happening. It's telling me you're still on branch master, your branch is up to date, but now you have some untracked files. It's print.py. Untracked files, and use git add to include in what will be committed. So this is basically saying me, I have some changes that are not in stage yet. So if you want these to be committed, you should move those to stage by running git add. So I'm going to do that, git add print.py. And now let's do a git status again. Okay, it's a little different now. It says changes to be committed. This is a new file. And if you want to unstage this file, you should do this. Instead, I'm going to commit this change by running git commit and add a message with -m add print.py. Okay, so it created a new commit now. Let's look at git log again. And now you can see I have two commits. Initial commit is still here, and then add print.py is added by QLaunch owner as well. So the next step is let's run git status again, see what's happening. That's why I said git status is really helpful. It's basically telling you what's happening with your repository. Now it's telling me you're on branch master, but your branch is ahead of origin master by one commit. Use git push to public your local commit. So what this is saying is now you have two commits, but your GitHub is it still has one commit. So you should do a git push. And when I'm running git push, it's going to ask for username and password only because I cloned the repository with HTTPS. So it's trying to identify me with my password. Normally you should use SSH and don't input your password every time. Hunter 2. So it made it there. Looks like it made there to master. Let's do a git status. It says, okay, I'm up to date with origin master. Let's refresh this. Okay, now print.py has made here, and I have two commits. So it looks like it worked fine. Let's click into two commits, add print.py. Yeah, it made it here. So I'm here right now. And the next step I'm going to do, I'm going to take off my owner hat and put on my contributor hat and fork this owner's repository into my own account. So I'm pretty much done with owner for now. I'm going to move out of owner's directory and move into contributor directory. So I'm a different person now. Here I'm logged in as contributor, signed in as QLaunch contributor. And somehow I'm magically going to find this repository that I came across on GitHub that belongs to someone else named owner. So I don't have, even if I clone this, I don't have permissions to push here. What I'm going to do is, I'm going to click this fork button right here. It's going to take a second. But when it ends, it's going to give me the same repository under my namespace now. So contributor/nameprint, forked from owner/nameprint. Exactly the same. Two commits, one branch that is master, and it's even telling me this branch is even with owner's master. So that's good. Next, I'm going to, right now we are here. The next step, I'm going to clone this fork into my computer. So I'm going to click this clone here, get the link, and now I'm in contributor directory. There's nothing here yet, so I'm going to clone. And this time the URL has contributor's URL. Previously it was QLaunch/owner, now it's QLaunch/contributor. Let's do this. Okay. So let's do a ls. The directory is here. I'm going to cd into this directory. to another ls, I have all 3 files that I was hoping to have. And if I do a git log, I'm going to see those 2 commits, add print.py and initial comment. So we are, where are we right now? We're at this state. We have exactly the same copy of the repository in 3 places. And most importantly, I have the local copy. The next step, I will check out a feature branch. And to do so, I run git checkout -b for the branch, for new branch, I think. And I'm going to name this branch full name. So as soon as I do that, it switches to a new branch full name. If I do a git status, it's going to tell me on branch full name, nothing to commit, working tree clean. Now, previously, when I was on master branch, let's check out master branch back and do a git status. It was telling me your branch is up to date with origin master, but now, if I do a git status on my full name branch, it's not telling me anything about being up to date. And that's because at this state, I don't have a feature branch here. My remote has no idea about this branch. So nothing is tracking that. Let's go back to feature branch named full name. And here, I'm going to modify this print.py file. I'm going to get rid of these 2 lines. And instead of writing first name, I'm going to print full name. So the new script is just read full name from the input and print it back. So save and quit. Let's do a git status. You have modified this file, but you haven't staged your changes. Before staging my changes, I want to make sure this works as expected. So Python 3 print.py. What's your full name? Let's give it a try. Welcome full name. So that works fine. Now we can add our change, git add. Let's do a git status again to see where we are. You run branch full name, and these are the changes to be committed. So let's commit that change, git commit -m for message, use full name. Now it created a commit in this branch named full name. So I'm going to zoom out a little bit so that it can display all 3 commits. I'm going to run git log, and you will see I still have the initial commit. I still have the print.py by owner. I forgot to change my name, but you will see use full name is coming from someone else. Here, the state is this. I have the feature branch with 3 commits and the master branch with 2 commits. So if I check out the master branch back and do a git log, it's going to show me 2 commits. If I check out the full name branch and do a git log, it's going to show me 3 commits. So this is the state I'm in. The next step is I'm going to push my local feature branch to my remote that had no idea that I even had the branch. And let's see what happens when I try a git push. It gives me a photo error saying there's nothing tracking this branch named full name. So it's telling me I should run this comment instead. So git push and set upstream full name. Origin here is the name of the remote. Git push that set dash upstream origin full name. This time I'm logging into contributor. And looks like it worked. So it says to contributor / name print, new branch, full name. Let's go back to the incognito window and see if it worked. So even without the refresh, it's telling me you recently pushed branches full name less than a minute ago. So if I refresh, it's going to show me 2 branches here. And right now I'm in master branch, and it has 2 comments in it. So if I switch to full name here, it's going to show me 3 commits. And if I go in, it has 2 commits from the owner and 1 commit from the contributor. So let's go back. Right now we're at this state, and the next step is submitting the actual pull request. And that's I'm going to do through the UI. There are, as far as I could see, there are 3 buttons that would do the same thing. So your recently pushed branches has this compare and pull request button. There's a new pull request button here, and another one right here. So any of those work. I'm just going to click this. And it shows me the UI that says open a pull request. The important thing here is confirming what you're requesting. So I'm requesting contributor's full name branch to be merged into owner's master branch and use full name. And when you're submitting a pull request, unlike my first pull request, you should always leave a comment. You should always say something nice. So hi, thanks for maintaining this nice project. This is the PR. Hope you find it helpful. Here's my reasoning. You know, blah, blah, blah. So once you click that pull request button, it's out there. And that's all I have with contributor. So I switch back to owner's login. So now I have here, I am signed in as KeyRaunch owner. If I refresh my repository, I'm going to see pull requests 1. And if I click that, that's going to show me the use full name pull request. And merging it as easy as just clicking this button. For sake of simplicity, I'm going to click this. I'm not going to explain the difference between merge and rebase. But as soon as you do that, it changes to merged. And if you go back to code, now you see my master branch has 3 commits. And the 3rd commit is coming from this other contributor. So that's the demo. I hope it helped to clarify this ugly graphics. And the last thing I'm going to talk about is where to go from here. So I'm hoping to give you a few pointers in finding where you can find a project to work on. First thing that they always tell you is think about the applications you're already using. So some of the open source applications you're using, they're looking for your help. And the good thing about that is you're already using that application, so you're already familiar with what's happening. So try to search for those applications and see if you can find anyone that can use your help. And the second thing I'm going to recommend is, since you're at SCaLE, you can just go to Expo and talk to people, see if they need help. They can use your help. Other than that, I'm going to mention a few challenges. For example, there's this Hacktoberfest challenge that happens on the month of October, and it's becoming more and more of a tradition. So during the month of October, if you submit a number of pull requests, they usually give you a free T-shirt. So while I'm not giving you the free T-shirt, you can get tons of free T-shirts during the month of October. There's also this challenge called 24 pull requests that runs from December 1st to December 24th. It expects you to submit 1 pull request for each day, which I found really hard, so I'm not doing it. But if you're into that, you can go to that. And the last thing I'm going to say, I'm running this thing called Pull Request Club, which gives you random assignments for a month. So every month you get a random code repository, and you're expected to submit 1 pull request to that random code repository. If you find a repository that you're interested in, go through its issue tracker, look for tags that looks like these. Those are usually pointed towards beginners and usually welcoming. If I remember correctly, on services like GitHub, you can also search for issues without specifying a certain repository. So for example, you can look for Perl projects that has issues with these tags. So that can be useful too. Once you find the repository, you can get in touch with them through Issue Tracker by opening an issue saying like, hey, I want to help. Do you need any help? What do you need help with? Or you can, if they're using IRC or Slack, You can go ping them there. Some of the projects are using mailing lists. Be careful, there might be multiple mailing lists. I am highly going to recommend the URL below for the full entry, but just to give you a quick summary of PR etiquette, always be polite, and I would add, always be patient. Follow repos convention. We talked about this. If they call themselves free software, call them free software. If they're using tabs, use tabs. Keep changes small means if you want to change 2 things at once, maybe consider submitting 2 separate pull requests. And that's where branches come really handy. So you can build 2 feature branches for 2 separate things and then submit 2 pull requests, 1 for each branch. And do the whole change means if you're changing a feature, make sure to update its documentation, make sure to update its tests as well. Lastly, I should have taken this out before, but I'm going to recommend some books here. First, the Forge Your Future with Open Source, written by VM Bresser. This is a great book that will take you from 0 to 100. It tells you everything you need to know about the open source, the licenses, how you find a project, how you should communicate with projects. And the other book I'm going to recommend is How Open Source Aids Software by Gordon Half. And this is going to tell you how open source has become what it is today. It's a great book and telling you the history of the book, of the open source world. And the last pointer is the pull request night, is Birds of Feather. We're going to have right in this room tonight at 7 p.m. So if you are convinced to give this a try, but you still need help, feel free to come by. I'll be here. And if you're offering help, also please come.
Test 1, test 2. Are we after?
It's 1:30.
134?
33, yeah.
33?
Do you want to wait?
Sure, wait till, because it's the lunch, right?
Yeah,
We'll
do you
just
want...
wait 2 more minutes, give it 135, just for lunch, break.
Sure, we could do that, yeah.
Well, hello everyone. We will start in just a couple minutes. I know it's the lunch break, so we're going to wait 2 more minutes just for any stragglers coming in. But pretty full room. I'm guessing there's a lot of you that think Python needs to be made great again. Is that cool? We're in good company. Yeah, we'll get started in just a couple minutes.
All right, good afternoon, everyone. Oh, is it on?
Oh, there's a little button to push up.
Yeah, okay. So today our speaker's name is Carlos Meza. He is an SRE at Everbridge, and he has developed tools for auditing compliance and security at Disney. Today his presentation will be on making Python great again. And if you guys have any questions, hold it for the presentation, and I will come around with this handheld mic after so that you guys can ask them. So without further ado, here's Carlos Meza.
Awesome. So I guess we're all here because I'm suspecting we're all Python users and have had our pleasures with Python and thought, like, hey, this language is pretty fun and great. And then all of a sudden, it stabs us in the back, and things begin to break, and our packages that once worked start beginning to fail. And we will go through how these things happen and how we can prevent them. So some of the difficulties I've ran into with Python, getting started with Python, is there's multiple versions of Python I need to support. There's isolations between applications and projects, and then we have project package and dependency management, all things that have caused my system to blow up at some point in time. But before we get into like how Python has failed me, let's start from the beginning. Python was great to begin with. It's very quick to learn. I mean, we're even teaching it to elementary school kids these days. It has a very vast ecosystem to allow us to get up and running. If you have not seen this XKCD comic, they even play to that point, saying, if the comic's just saying, like, you have your little Pythonista floating away and you have the developer on the ground. How are you doing that? And the TLDR, he's like, oh, I imported anti-gravity, or it was all the stuff in the medicine cabinet, one of the two, but you know, it was probably Python. And today you can actually in C Python do import anti-gravity. Spoiler alert, it just takes you to this URL. And even on python.org, it says that it lets you work quickly and integrate systems more effectively. And I kind of agree. I've gotten to leverage it to do a lot of interesting things to make my life a lot easier. For instance, Once upon a time, I was working at Verizon on the EdgeCast CDN, and there we were leveraging Python to build and manage our private cloud on top of OpenStack. OpenStack is built, all the glue that makes OpenStack run is in Python. We are also controlling and provisioning our infrastructure with SaltStack. So Python was also letting me manipulate a global infrastructure. So I think that's pretty cool with Python. Today, I'm at Disney using Python for compliance enforcement between AWS's Boto 3 and Capital One's Cloud Custodian, where Python lets me easily query my entire infrastructure and then make changes accordingly and alert on things that don't appear to be the way they should. So even this presentation is created with Python. Oh, and I forgot to do something and reset the slides. Give me 1 second. But yes, this talk is demo heavy, so brace yourselves. Sorry, just going through my bash history to restart my Python environment. You know what? So it's a little less boring. You can see how the sausage is made. This is inside of Jupyter Notebooks, running Reveal.js. So I have a whole house of cards going on here. All right, I think, let's try this again. Let me try one more time because now my fonts are all off. All right, again, even this presentation is created with Python. And I'm not connected. All right, there we go. Even this presentation is created with Python. And I did just execute that code. I can run it again, and, well, it just blinks. But we'll see. Again, this is demo heavy. This all worked an hour ago, so let's hope it still works. But Python, right. So Python is also fun. Just for the lulz, look how fast I can make a meme inside of Python. TLDR of this script, of this code, I have some obfuscated text, I decode it, I load an image, and I slap the text onto the image. Bam, we have a meme. So I execute the code, and let's display the image. Python is great until it isn't. So what happens with Python? Well, using Python sometimes is not the most fun experience. Here in yet another XKCD comic about Python, it's displaying how all the different ways we have to manage Python, if we're using Homebrew, Anaconda, we have different versions of pip going on, and then but at the bottom of the comic it says, my Python environment has become so degraded, my laptop has been declared a Superfund site. So yes, Python can get unwieldy pretty fast. And then things begin to break. Whether it's inconsistencies in prod, you try to share code with your teammates and their laptops are inconsistent from yours. Sometimes Python apps that were once running all of a sudden stop running on your laptop and throwing exceptions. There's dependency issues, and then your system Python's all borked. And then we are a sad Pythonista. But these problems are not unique. Ruby and JavaScript have had these same problems, but they have solutions if you're familiar with tools like bundler and npm. Python has a solution. We can bang on prod till it just works, but maybe that's not the best idea. But Python does have some real solutions, maybe too many solutions, and then especially when you're coming into the language, and even as someone that's been doing the language for a while, it's like, which tool do I pick and why do so many exist? Well, that's what we're going to talk about today, and I'm here to help with a workflow and solution that will make life so much easier and make Python great and fun again. So it can be great again. We will be talking about PyEnv, pipenv, and pipx, and we will be demoing all these tools. But first, what's not so great? I'll be starting with pipenv, and why do we even need pipenv to begin with? There are so many versions of Python that need to be supported. Right now, the 3 versions that are actively being maintained are 3.5 through 3.8, which all have their different sets of features. So if I'm running a library that uses data classes and I have 3.6 on my machine, it's not going to run. And for those of you who thought we were done with Python 2, think again. There's a lot of quote-unquote enterprise-grade software out there that is yet to be converted over. Even some projects like Calibra are still in the middle of transitioning their code base to Python 3. So you may be in a situation where you have a very real need to still support EOL versions of Python. And then there's System Python. While technically not a version per se, but it is another copy of the interpreter we need to be cognitive of. System Python belongs to the system. We shouldn't be mucking with it. We have less control over it. I mean, if you go, sudo pip install, you're going to have a bad time and break your System Python. And I've definitely learned that the hard way. But things can be better, and that's where PyEnv comes into play. So it helps us manage versions of Python. It can install not only different versions of Python, but different builds of Python, because I support both CPython and PyPy, and I can have them all living side by side very happily. And PyEnv lets me switch between the interpreters very easily. So let's get into a demo and see how it works. So installing any version. Let's take a quick look at what's available. So I've just grabbed out the latest versions of Python 3 available, and you can even see like any point release, release candidates, and even development branches are all available for us to install if that's what we need. Awesome. So let's install Python. I'm just kidding. We're not going to sit here and watch me install Python. But I have pre-staged a few versions of Python. On my environment, I got our System Python 2.7, 3.7, 3.9, and even a copy of PyPy. Awesome. So which Python's actually going to run when I do type Python 3 -- version? Well, right now it says 3.9. Why is that? So PyEnv version gives me back how I prioritized my Python interpreters. And you can even see where it's set by, and there's a .version file living within my home directory that PyEnv references. So, cool. So the other versions of Python, if I do 3.7, hey, it works. And I have Python 2 installed, correct? It is installed, but it was not active. And PyEnv lets me know that, like, this version you're trying to run, it's here, I found it, but you told me not to use it. So PyEnv lets me temporarily switch if I need to. So PyEnv shell lets me reorder my priority of my Python interpreters for the bash session. So I do PyEnv shell. In this case, I'm going to throw 2.7 at the beginning, and I'm going to prioritize 3.7 over a more stable version over our dev version of 3.9. And I go ahead and execute that, and you see that 2.7 is now at the top in the exact same order listed. PyPy is no longer selected. So let's verify that it actually does what I say it's doing. And when I execute Python 2, I get 2.7 back with no errors, and Python 3 now gives me 3.7. Great. If I need something that will persist over bash sessions, I can set versions, I can set overrides per path. So that's where pyenv local comes into play. Here it's like, I want my default to be 3.7. I need Python 2.7 available, and just in case, let's throw 3.9 at the end. And I do that, and now 3.7 is my default. Wonderful. Just to prove the point, 3.7 is first my default in the same directory. I cd to root, and we're back to our previous global default of 3.9. Yay, it works. Magic. Not really. It's just dropping a file .python version. Some of you from the Ruby world may recognize this from that Ruby has something similar with the Ruby version. So these patterns are not unique, and so it makes my life a lot easier, so I can just cd and start running with the right version of the Python I need for the scripts in that directory. So, and I can clean up after myself with just pyenv local -- unset. And now that it's unset, when I run local, it throws me an error saying it's not configured, which is to be expected. Wonderful. Python's getting better. I don't need to worry about having all these different interpreters on my box and how to manage them. Now I can use any version of Python. I'm not stuck. I can install any package. I can update my packages even if they want to change to the latest version of Python. I can still be happy. I can test against multiple versions, and I can switch in between interpreters, and I can create virtual environments with any version. And we'll be talking more about virtual environments later. So, but there's more that's not so great. We have 2 more tools to cover, but first, why do we need these other tools as well? Because there's dependency conflicts. And if you've ever, like I said earlier, if you just ever pip install right into your system, you're overriding your repos, packages, and things are going to get out of sync, and it's not fun. For example, this is what happened to me with SaltStack before. I had one library using, I had one application that needed access to GPG. And it's like, great, we have our installed, we have Python -GNU PG, so we can talk to GPG. Wonderful. I load it, and I see the module name is GNU GPG, and it's the exact same version. Nothing surprising, exactly what we expect. Then I'm working along. I'm like, I need another tool to do my job, and I go ahead and install it. And it also needs GNU GNU PG. But it decides it needs a different library. But yet, both libraries import as GNU PG. As you see here, now we have 2 different libraries, 2 different versions installed. So when I go to import GNU PG, which one's going to load? Does anyone want to take a guess?
Depend on the version of the first thing. So it's probably you would choose the lowest one.
So we got possibly the lowest one of a version-wise.
Take the, I think it depends on the file. But I think it's the regular GNU
in this order. So, because I've been playing with this, it is deterministic, but I wasn't 100% sure it's based on the higher version or alphabetical, but it's probably path actually as I'm thinking about it. But so, yes, the new one does install, does load now. That's just some code to force it to Python to reload the module. And we've reloaded, and we're now at a completely different library. That means all the existing packages that were installed that were using the previous library are now going to explode because they don't have the same APIs. Wonderful. And just out of curiosity, what if my system Python was using GPG? And oh, guess what? there's yet another library for GPG. I'm guessing this doesn't import as GNU PG, but still, I think you get the idea that like this could set up for a bad time. You know, here, if I installed it in my system would be borked, everything is broken, you know, game over, format the box, redeploy your distro, and try again. Great. So, yeah, the world's over. Go home for the day. You can try again tomorrow. Python does have a solution. They give us virtual environments. Virtual environments provide us isolation between our projects. We get a copy of an interpreter and our own set of dependencies. So, great, as long as the packages we're using don't do what I just did there, everything should be happy, right? Well, have you tried using virtual environments? I don't enjoy the experience. This is a standard workflow for using in a virtual environment. Top line, we're setting our version of Python that we're using. Then I import the virtual environment module and create my virtual environment. Then I activate the environment. Then I do some stuff in that environment. Here, I'm just going to display which Python 3 executable we're using, and then I'll print do a pip list to show the environment. And then we deactivate, and then we get to do this whole song and dance again for the next tool or project we want to work on. Oh, well, sorry, let's actually execute it. Personally, I don't find this enjoyable. And now we have to create an environment for everything that we're working on, whether we want to run a tool, whether we want to work on a project. So that means we now get to manage virtual environments. And I don't want to. That sounds like too much work. I didn't start learning Python to do more work. So there is a better way. Today we have tools like pipx and pipenv. Pipx will deal with the virtual environments when we're wanting to install or run applications, and pipenv will help manage our virtual environments if we're developing it on projects or libraries. So more demos. Let's see how pipx works. Again, for running and installing our applications and keeping them nice and isolated. So let's install a thing. I'm going to pipx install pyjokes, because sometimes I need a little pick-me-up. And just like pip install, pipx install brings in my package, and the output tells me what version. We got 0.6. The version of Python, our default is 3.9, and it even put 2 executables in our path for me. So that means now that pyenv is installed, pyjokes is installed, I just execute pyjokes, hey, it works, and it returns a number of days since I have encountered an off by 1 error, 0. We can do better. Software developers like to solve problems. If there's no problem handily available, they will create their own. Sounds about right. So where did it actually go? So if I do pipx list, and if you've seen the pattern, very similar to the pip CLI interface, it lets me know right off the top where the virtual environments are living. There's a path underneath my home directory by default. Where the apps are getting exposed to, it puts a .local bin in my home directory that is part of my path. And then we see that pyjokes is there second underneath pipenv. We'll be talking about pipenv shortly. So wonderful. It's all nice and isolated. And we can easily get rid of it. Much to probably no one's surprise, we do pipx uninstall pyjokes. And now it's gone. Wonderful. Though what if it wasn't ready to run with 3.9? Well, pipx also lets me define what version of Python interpreter I want. So with -- Python appended at the end of install, I can do -- Python install Python 3.7. Let's give it an actual supported version of Python. And it goes ahead, reinstalled, and now it even says, like, now I've installed with 3.7. Awesome. So I can now leverage the I can leverage pyenv with pipx so I can support whatever application I need to install. But it can do even more than that, because what if there's just a tool I want to run one off, or just I'm just testing. I don't necessarily want to install it and have to uninstall. We're doing more work again. I don't like to work. So I can get a temporary sandbox. I can just do, I can do a pip run and get a temporary virtual environment. It will build a virtual environment and clean up after itself for me without me ever having to think about virtual environments. And so let's run a Python implementation of CalSay. And I do pip run CalSay, and I pipe in fortune, and he who laughs last is probably your boss, I suppose. So did it install? We do pip xlist, and we only have our PyJokes and pip env listed. So awesome, Python is better. I can run tooling without managing my virtual environments. I'm a lot happier. I have all my tools nice and isolated rather than pip installing -user all the things and watching them crash. So we still got to deal with development environments, right? So sometimes I need to write my own libraries. So pipenv provides a workflow that will manage our virtual environments for us. So let's just take a look at that. We will start by writing a script. So CalSay is cool, but we're at SCaLE, right? Let's try tuxsay. So very simple script. I'm doing a lot of cheating. CalSay actually provides me tux. So I just swap out all it's doing here, I'm importing CalSay, and then I'm reading from standard in, and I'm telling it to execute the library CalSay with tux and passing the phrase from standard in to it. So awesome. Let me actually write the script, because this is all live. And OK, but I need my virtual environment with my dependency CalSay. So pipenv to the rescue. I do pipenv install CalSay, and it will load up a virtual environment with my dependency. And you can see here, we've created a virtual environment. It's adding CalSay. Well, that's not where I'm installing CalSay. It is mentioning this pip file, and we will touch on that in just a second. But we built a virtual environment. It says it installed our dependency. Wonderful. Can we run our script? So pipenv run will automatically run inside the virtual environment for us, and then I'm running, then I'm executing Python 3 and my script as I would normally. And hey, it looks like it works. So real quick, what is this pip file about? It can replace requirements.txt. So if you notice here in my packages, I have my dependency now. And I can even tell it what, if I don't want to use PyPy, say I have my internal Python repo inside my enterprise, or I can easily point to it there. I can actually have a list of several repositories here if I needed to. So wonderful. So let's move on to creating an actual application. So let's turn that tuxsay into an actual full-on application. So we need our standard setup.py. I've actually moved our dependency into setup.py because this is where we should be putting our abstract dependencies. And I've also created an entry point so it can actually install a CLI tool. So cool. I'll write my file, and I will update my environment. Rather than just editing the pip file in front of everybody, I will just blow it away and let pipenv rewrite it for me real quick. And I do a pipenv install editable, and I just point at my local directory to install the local files. Rebuilt it and added tuxsay to the pip file. So did it actually work? If I do pipenv run my CLI tool, and it looks like it works. And I have passed in pipenv -ve nv, and which will return the location of our virtual environment. So wonderful. Looks like it's working, and I haven't actually had to deal with the virtual environments directly myself. But what if I need some development tools? I am a big fan of Pilot. You should be always, if you're not using Pilot, Flake 8, something, please link your code. So with pipenv-dev, I can note that this is a dev tool, but when I go to rebuild my dev environment, I can get exactly all the dev tools I need. I should have really put some sort of version bound there, and I guess I got lazy, but yeah, you should be bounding versions that you're installing. So what does the new pip file look like? So under dev, we have our development environment, development tool. So if you want to install other things like iSort or anything else you might be using on your code. And then under packages, normally I only have the code that I'm developing listed here with this editable install and path dot, and then I put all my other development tools under dev. That's how I use it, because all my requirements for the application itself should be in setup.py. That way when somebody else goes and installs it, they don't need to understand pipenv. The other developers on my team don't even need to worry about this. To me, this is an easy tool to adopt, because it doesn't force other developers to change their workflows either. But that doesn't mean you need to be exporting your requirements.txt file, because if that's still what they're using. Eventually, this should be replaced, and I'll show you another feature of why the pip file is superior in just a second. But first, we can clean up after ourselves, and with --rm, I have destroyed my virtual environment. And we can rebuild and even specify whatever version of Python we want. So very similar to pipex, I can just add --python, and if I don't want to install the latest because production is using 3.7, so let's just develop in what we're deploying on, I can easily do that too. And you see that we are now using 3.7 instead of the environment's default of 3.9. And everything is rebuilt. Even somewhere in here it should be listed. Oh, I guess maybe there's not enough help. I was going to see if it's telling us that Python's installed. We'll see it in a second. It does throw warnings because the pip file does specify that we are installing that the environment's supposed to be built with 3.9, and I overrode it. But for the sake of the demo, I just blew past that. But yeah, we can specify the version of Python we want as in our pip file as well, so that way we get, again, consistent environments. So pipenv also helps with our dependency resolution. And this is where I think the pip file is superior to pipex. But people normally use the requirements.txt file with pip. So let's take a quick look at our dependency graph. And you can see tuxay at the bottom is very simple. It just has calsay as our dependency. But over time, our dependencies can get more complicated. If you take a look at Pilot, it has a dependency of asteroid, which uses 6, and a variety of other libraries, which all have different bounds of version requirements. And making sure all these dependencies play together nicely can get unwieldy. Just for a more complex example, we can take a look at what my presentation is running in. And you can see right here I'm using Rise, which requires Jupyter Notebooks, which requires IPyKernel, which requires IPython, and things scroll away and get out of control really fast. And some of you who may have worked with projects with these kind of dependencies may be very familiar with dependency hell. So pipenv helps us get out of that kind of afternoon, or even days trying to sort that out. So how does it do that? It can generate a pip lock file for us. For the presentation, I had overridden it with an environment variable because it takes more time for it to sort all these things out. And you can see I had used pipenv skip lock equal to true. But let's do it once just to show you what happens. I'm going to forcibly tell pipenv to lock. So even though I have it set, I'm telling it, no, please write my lock file for me. And you see here, It's building our lock file, and we will take a look at it in just a second. One more second. Any second. So it does take a little time. This is why I had disabled it for the presentation, so I wouldn't have to hit this every time. Great. Our pip lock file is written. And this is where concrete dependencies go. So in our setup.py, I had a bounded version of my dependency calce. Here in our pip lock file with the concrete dependencies, I just grabbed a piece of it with a JQ. We can see my dependency calce, and it's pinned to a very specific version of calce 2.0.3, and even has the hashes there so that when I pull from PyPy, I can confirm it is the exact same blob I'm getting from PyPy. So this is why I think this is superior to using the traditional requirements.txt. I don't have to manually go in there and try to figure out and pin every dependency myself, and it will do the hash checking for me. So if I have somebody trying to do some sort of man in the middle and drop me some sort of payload, this will catch it. So even this presentation's environment was created with pipenv. And there's my pip file. You see I had pre-staged my GNU libraries for the demo. I had Pillow for when we made the meme, and there's Rise. So I like pipenv because I can also create arbitrary virtual environments for doing things like this. Because I didn't create a package or even a script here, but I still needed a virtual environment. But now I don't have to manage it myself. So this is like SCaLE, and some of you be like, okay, that was a lot. Why do I care about all this? Because what we just did here is virtual environments are an implementation detail. I don't have to care about them too much anymore. I can still get in the weeds if I want to. So Git talks about having porcelain and plumbing commands. So to me, having pipenv and pipx are my porcelain commands, where pip and virtual environment are my, did I say that right? Pipenv and pipx are my porcelain commands, and pip and virtual environment are my plumbing commands. So I can get into the weeds if I want to, but I don't have to anymore. So TLDR, I can now manage multiple versions of Python. I can keep all my tools isolated, and I can keep my development environments isolated. So without ever having to think about virtual environments again. What do you think, Tux? I use pipx run to my application we just made, and hey, Tux says Python is great again. This solution uses the Python Packaging Authority's recommended tooling. It works with core Python libraries and tools, and even at this upcoming PyCon, there's a workshop teaching these tools and more tools, but does teach these tools. So I think I'm on the right track with this set of tools and workflow. Again, like I said, PyEnv for the version management, and abstracted away pip and virtual environment with pipx and pipenv. So Python is great again. We can let our children play with all the Pythons. And yeah, these slides are already available. I probably need to get push what I just did right now. But the last version is up right now on GitHub. Yeah, is there any questions? Yes, sir. Oh, thank you.
Any easy way to install pipx without brew? I'm not allowed to use brew.
So what I do with pipx, so there's two ways. There's what I'm doing right now is I just do pip install -- user pipx, and that's the only tool that goes into like my area. And then it doesn't have to go into every version of Python. It just has to go into whatever your default is that you're using. But there is another library out, and previously pipx used to install this way. It used to build itself a virtual environment, put itself in there, and that way it would install as one of the tools, like how you saw PyJoke, and it would install like that. There is I believe, a repo called pipx in pipx, which has a setup.py that does that magic for you. I haven't used it, but I do want to start using it because that just seems more logical to me. So yeah, you don't need brew. Yes, sir.
So at the beginning you installed a couple different versions of Python. Where did they come from?
Oh, so the question is, where did the different versions of Python come from at the beginning? So I'm pretty sure, I need to verify, but I'm pretty sure the C Python came from wherever python.org publishes the tarballs, and the same thing with where PyPy publishes them. I'm pretty sure that's where they're linked to. I need to go check and verify that though. Of course, PyEnv is a very nice. All it is Bash. So, and of course it's on GitHub. So it's all there, and I'm like pretty confident it's just pulling from the source of the Python of the build for those Pythons. Not out of version control, but you know where they publish their like their tarballs. Oh, actually, PyEnv can also fetch you because it will compile any of these builds you want as well, and it can either fetch source and compile for you, or it can if it can find a pre-built binary that matches your system, it will just pull that down too, so you don't have to compile the whole world as well. Anything else? Yes, sir.
If you have several versions of Python installed on your system, like just from your regular package manager, can Maven want to pick up all of those and use those, or just have to install them from whatever system you are?
So the question is, how does pipenv play with the system's multiple versions of Python from the system? So I'm honestly not 100% sure. I know I've been in this situation before during the whole Python 2, Python 3 crossover where my distro was installing two versions, but I don't generally point at my system versions. I only point at my installed versions, so I'm not 100%. But I would expect if I told my default version to be my system Python, it would use Python with no number after it as Python 2, and then Python 3 to be whatever the system's Python is, if I told PyEnv to use the system as default. That would be the expected behavior, but I generally never list my system Python in my set of available Python interpreters. So, not 100%, sorry. Yes, sir?
In conjunction with like an IDE like PyCharm that has some of these features, or are you using this more with a regular Sublime type text editor?
So my two editors of choice are, I'm going to say something opinionated, Vim, and I do like PyCharm for my IDE, and PyCharm works with pipenv. So whatever I've told my pip file to build with, PyCharm will go ahead and pick up whatever it needs to pick up, and it will figure out what Python if I've defined the Python interpreter, it will go and figure it out, and will work 100% with my with PyCharm. It also has VS Code support as well. But when I use Vim, I am doing things a little more manually, so I've already have it all ready to go when I'm launching Vim.
So my second question is, I've been kind of wondering if containers could be leveraged to kind of deal with this kind of general problem. Has anyone
you want to have a
tried
packaging talk? We can do that too. Yes. So there's different. So are you asking if to just ship the entire thing inside of a container? You have your interpreter, you have your dependencies, and like, who cares about virtual environments? You got your container. So I like shipping my software like that, but I don't necessarily do that for my development environment, because then tying my IDE inside the container and doing all these extra hoops, I don't like working like that per se, but I do like shipping my software that way. But that's a whole nother rabbit hole of how to package software and how, like, I mean, we can ship it as a VM too, like how, like, or we can like, so yeah, I ship personally my projects. I put my Docker file, my Docker Compose, and make my nice little blob that gets on the Docker Hub. And then I also have my installable package so it can be leveraged as a dependency on PyPI. So I ship it all like that, and then it's up to the user, however, whatever fits their use case the best. Yeah. Yes, sir?
Pip is about a little over 3 years old now. It still seems that requirements.txt and pip is still the norm. What's stopping pip from more widespread adoption?
So the question is, what's pip env being several years old? Why hasn't it been more widely adopted where requirements.txt is still the standard? So I don't know. Maybe I probably live in a bubble. Like, to me, like, it's gotten like wide adoption, especially after so the Python Packaging Authority endorsed it, and it got more adoption. There has been some community back and forth on how to move forward. There's been pushback on PyEnv for so let's air some dirty laundry. So PyEnv did have some bumps when it was first getting off the ground. They were developing really fast and changing the UI out from under people, and that wasn't creating a great user experience. That has stabilized, but now things have gone to the other direction where the maintainers are trying to pay off technical debt, and they've been really slow to have a release, and that's made people uncomfortable. On top of which, new standards are coming out. And so now we have there's a competing tool. So there are more slides for these questions. So there's a competing tool that often gets compared, like people are just use Poetry, but it's not solving the same problem, but it seems to get in the same conversations. And Poetry does not work with standard tooling, because if you don't have your setup.py, you can't do an editable install with pip, and like, so there's all these, like, the Python, and this is why we need to make Python great again, because it suffered from, like, there's all these different competing ways to do things, and then they don't always have the greatest interoperability. So I actually really like Poetry, but it's not solving the same problem. No editable install. Oh, I even demo it, but these are the reasons that I'm stopping from it, because like I couldn't write this project in Poetry because I would needed just an arbitrary virtual environment. Poetry is really to package your Python application, so I'm not trying to do all that scaffolding and setup. If I'm doing all that work, let's just go back to using virtual environments the way they were. And it's still lacking a couple of features, but it's gaining adoption. So people are now putting effort here instead of pipenv, even though they're two different things. But I do continue to think pip, like, to me, I like that workflow a lot. That's why I say pipenv is a solution. It's gained adoption. If the Python community, the whole thing about the Poetry not working without setup.py is not a fault of Poetry or pip. That's actually, there's no actual standard on how to let that for that use case for that situation. Even though Poetry uses this new standard where we have pyproject.toml instead of all those files, but it's like, well, what about all the tooling that's still expecting setup.py, and like, because that's more of a setup tools feature. So what is pip supposed to do in this situation now? So Python continues to evolve and hits, it's like, oh, we have new features and a new bug. Like, so I guess I danced around your question a little bit. Like, I didn't answer exactly what's slowing it down, but the Python community, as you saw, we have, my earlier slide, we have 1 million solutions. Those are the kind of things that are slowing things down because we're not coming together as a community to be like, this is the way we do things. This is our bundler. This is our NPM. This is how we're doing it. And so that's probably the biggest reasons that are holding up a standard and adoption. Any more questions? Comments, criticisms? I was really happy with this slide. Oh, yes, sir.
What are your thoughts on using Docker? I know it solves a different problem, but instead of using like a pip just using different, containers to run different versions of Python.
So having different containers for different versions. I did that early on, and it was difficult. I mean, if you have in your container your Vim and everything, or you're like just, I guess you'd be probably mounting in your volume that you want. Yeah, that can work with Vim and things like that. But if you having that whole IDE experience, it can get a little unwieldy. It's doable. If that works for you, that is a solution. You can run your talks and everything you need to do your testing, and it can work. I used to be 100% Vim, and then a coworker showed me what I can do with PyCharm, and I was just like, oh no, I need an IDE. So you could hook in remote editing into your container, but now I'm doing more work again. So if you haven't noticed, I didn't start programming to work. I'm lazy, right? So yeah, I mean, it's a workflow. If it works for you, wonderful. If you have your environment and your tooling and all working like that, it's definitely a viable option. But this is more of the common workflow and toolings where this pattern, my teammates don't have to use pipenv with this pattern. They don't have to use pyenv or anything. I mean, they can blow up their system however they want. But so that's what I also like about this. I'm not imposing a way of doing things. Like if I use poetry, now everybody that's contributing to my project has to learn how to use poetry. It's it's tied to it. So that's why I'm advocating this process.
More elegant solution.
Yeah, more simple, elegant. Sure, thank you. I'll tell you, it works for me. Not everybody wants to run Docker on their machine sometimes. But I love it, but not everybody does. Any other questions? Well, if not, I will let everybody. Oh, yes, sir.
I don't see the microphone, so I'll just speak up. I'm curious, do you have a methodology for moving? Because I share a lot of code, so what I'll do is I'll develop locally with my local tools, and I want to put it into a container that I ship to another developer to use. Do you have a pipeline for moving that? Do you still use pipenv inside the container, or do you drop it and just rely on the container?
Oh, so inside the container, yes. So in my CI/CD builds that are launching inside of a container, I have a pip file on my personal project because I don't have the requirements.txt. And the way I leverage that, because I don't want it to build a virtual environment inside my container because that just seems like a waste. Pipenv does give a -- system and will install right into where the system is because my container already is my virtual environment. So yeah, is that what you're looking for, like a -- system, and that way, here's your container. But yes, I do have to bring in pipenv into the container so I can actually execute on that. Any more questions? Well, if not, I don't think there's a talk after me. So unless you guys have other talks to go to, the expo floor is still open. So thank you all for coming.
Thank you so much.
Does the mic work? Yeah, it does. All right, here we are. Yeah, all right, cool. So we're getting started now. Hello, everyone. Thanks for coming. We're a little late, but that's fine. My name is, I'll go into that in a little bit, but I've been going to SCaLE for years. This is my first time on the other side of the stage, so I'm really excited to be here. So, all right, who am I? You get it? Owl who? Anyways, so my name is Aaron Turner. I go by Torch2424 on the internet. I made that name when I was 6. You know, things happen, and I do a lot of things. So I'm a member of the AssemblyScript team, which is a TypeScript-like language to WebAssembly. So you can write a TypeScript-like language, kind of like using a JavaScript workflow, but it compiles down to WebAssembly. Also the author of WASMBoy, which is a Game Boy emulation library written in AssemblyScript, so you can run Game Boy ROMs and things in WebAssembly. Also the author of WASM by Example, which is a bite-sized website of like just copy-pastable examples and kind of learning by doing. And I also made with WebAssembly, which is just a showcase of a bunch of different projects using WebAssembly, either in production or like personal things. A lot of them are production, so that's really exciting to see. And then I'm currently working at Fastly. I joined 1 week ago, so but yeah, I'll be working on the WebAssembly efforts there on more like edge compute type stuff with WebAssembly. So cool. Let's get into our agenda. So we're going to be talking about WebAssembly. I mean, it was in the title, and we're going to be talking about what it is and why we're talking about it. Then we're going to talk about the WebAssembly system interface, and what is that, and what is the system interface for this WebAssembly thing. And we're kind of going to explore how WASI can relate to containers and containerization in terms of like deploying and bundling up your apps. And then we're going to talk about building these WebAssembly modules and how we get started doing that, and then kind of wrapping it up with where we can run these WebAssembly modules and how we can use them on our servers or in production or whatever we want to do. So first, what is WebAssembly? This is a picture from WASM Summit. I helped organize it, and it's the first WebAssembly conference that's ever happened. It happened about 2 months ago, and so yeah, WebAssembly is really getting up there. But what WebAssembly is, it's a bytecode on the web. So it's a universal, low-level bytecode. It can run in browsers and things like that, and that's why it's kind of on the web. But because of this, WebAssembly is really great for running logic-heavy tasks compared to something like JavaScript. So you can do things like image manipulation and physics, like physics for games, for example, and heavy math computations. But what makes it so great for this? Let me go to the next slide. Boom. All right, cool. Mouse stuff. Anyways, so what WebAssembly offers is predictable performance when you compare it to something like JavaScript, because JavaScript needs to be parsed, evaluated, and then compiled many times through a JIT compiler or a just-in-time compiler. And this can get extremely fast because it can make the right assumptions, or it can fall off this fast path and it can get really slow. What bytecode offers really is this predictable, kind of consistent performance because it just runs the byte straight through. And yeah, that's why you get this really good predictable performance, especially in a browser use case. One more thing about WebAssembly is that it's very portable. So it runs on all major browsers, so Chrome, Edge, Firefox, Safari. You could ship it today. It runs in Node, so you can, for example, if you have a big Node app and you want to speed up some hot areas of your code, you can go ahead and replace it with WebAssembly there. There's also standalone runtime, such as WASM time and Lucet, which is all about just running a WASM module straight and built on top of that WASI thing that we're going to talk about in just a little bit. And it's also very bundleable in terms of like, I can throw WebAssembly modules on NPM or whatever you're using for your package management and things like that. And on the terms of being portable, there's a lot of languages that are outputting WASM today. The most mature 3 right now are AssemblyScript, which is the one that I'm helping out with, the TypeScript-like language. And to dive into that a little bit, by TypeScript-like, I mean like you can't just take a React app that's written in TypeScript and just compile it to WebAssembly. WebAssembly in its current form doesn't really have like DOM access and things, and that needs to be given by the host, but we'll get into that as well. And but what's really nice about it is it has mature, really small bundles, and it has some really nice tooling, such as Aspect, which is great for testing, and then ASBind for that binding between your host and your like actual WebAssembly code. Another one is Rust. Rust probably has the best tooling right now. It's an amazing ecosystem for WebAssembly. And yeah, pretty much there. Rust is a great option. And then Unscripted, which is a tool chain for C. It's extremely mature. You maybe have heard of it before. It started off as like a project that would take C code, which it still does, and then compile it down to ASM.js, which is just a super fast, like optimized version of JavaScript. And now it's kind of evolved into taking C and C++ and compiling down to WebAssembly. So some other neat facts about WebAssembly is that it uses linear memory, meaning you kind of get this single heap or like array that you're designated that your WASM module can use, and this makes it really easy to sandbox because you don't have to worry about multiple WASM modules or other things being like, hey, I want to point into that memory. It's like, no, this is mine. This is my sandbox. This is my memory I get to use, and like It's for my module. And this means you get some really good security implications from this. And another great thing about WebAssembly is that it relies on capabilities. So a lot of the security model behind WebAssembly is capability-based. So the host, for example, would provide import functions, and then the WASM module, which you would call the guest that's running inside the host, can then call these import functions to do something on its behalf. So for example, like we mentioned earlier, in the browser case, there's no direct DOM access between WebAssembly and like the actual what you see in the browser. So JavaScript can provide a function to say, hey, I want to like draw a div here. JavaScript can go ahead and like draw that for them and then return back to the WASM module after it's done. But cool. Now let me understand a little bit of the WASM fundamentals and kind of the concept behind it. What's this system interface for WebAssembly? WebAssembly system interface, or we're going to call it WASI from now on. From my understanding, it's a standardized set of system calls or other operations that allow for interacting with system resources. In its current state, it has great support for things like file system, randomness, and time. And eventually, it'll kind of get more into like networking and accessing user devices and things. And this is really great because what you can really have out of this is you can have predictable performant modules that are sandboxed by the linear memory and have access to the host functions and resources that you grant it. So and it's all on top of like a standardized set of system interfaces. So you don't have to worry about it like moving from Linux or Windows, and it's going to work because it's all standardized. And now here's the big hook for my talk. So this is a tweet that came out a while ago. It's a really exciting statement. You may have seen it before, but it's by Solomon Hykes, and they're the co-founder of Docker. And I'm not going to read the whole tweet, but the TLDR of it is, if WASM and WASI had existed in 2008, Solomon said that they wouldn't have needed to make Docker, and that's a really big statement. Owen Wilson, wow, that's a really big claim. So there's a lot to unpack here, but let's explore how WASM and WASI can solve similar problems that modern containerization is solving. So to see what problem we're solving, let's take a look at kind of like the original architecture, or the virtual machine architecture, for when it came to like containerizing and bundling your applications. So virtual machines, what they really offered were isolated sandbox applications plus its dependencies. But the thing about virtual machines is they had the bloat of an entire guest operating system underneath it. So this was really slow to start up and wasted a lot of resources because you didn't really care about the operating system. You just wanted to run your app. So container architecture, which kind of like your Dockers and things, what they improved on is that they're also isolated in sandbox applications plus its dependencies. But they are isolated in process that share the OS kernel. So that removes the operating system that's underneath, and that removes a lot of the bloat. So there's much faster boot up and less resource usage, which is really nice. Now, let's kind of see how WASM and WASI relate to this whole container architecture we look at. So instead of having your application as dependencies in a container, you could just compile them all down into a single WASM file, that WASM module. And then you can use a WebAssembly runtime that will then run those WASM modules on your server or whatever you may be doing. And that can either be in one runtime, like one runtime will manage multiple WASM modules, or you can just have multiple runtimes because let's say you have an application that runs really well in WASM time, but something else wants to use Lucid for whatever reason. And again, there's no operating system bloat here, so that's really exciting. You get that fast startup. But cool, so they're solving a very similar problem. You can kind of see how they can interleave. But is there like any other differences between containerization and using just WebAssembly and WASI? The first is WebAssembly modules are very small. So for example, they were designed to be small because WebAssembly kind of originally started off as a thing for the browser or just the web in general. So if things can be shipped down on the web, they can't be megabytes on megabytes. And probably my best example of this is I recently did an assembly script module, and I think it was about 100 bytes for a hello world, which is like really small. And then and later on, we're going to be showing a JavaScript engine compiled to WebAssembly. And just as a quick before optimization, it was 2.5 megabytes, which is like fairly small for like something like a JavaScript engine. And then on top of that, the WebAssembly runtimes that are running these WASM modules, they tend to be very fast and use very little memory. So since it's a runtime, it essentially just needs to take that WASM module, read it in, and just execute it. And they can do some additional just-in-time compilation if they need to. But yeah, it depends on what your application does best in. And some runtimes like Lucid, they're an ahead-of-time compiler. So because they can ahead-of-time compile the WebAssembly module, they can go ahead and have startup times in microseconds, which is really impressive. And most of the memory usage going on here is towards just that linear memory, whatever the module requests it says that it needs. So that's really nice because you don't need to request more memory than you actually need. And then just on the same topic of being small and fast, there's even WASM interpreters like WASM 3 that are used for IoT applications. So they have extremely constrained memory and CPU, but yet WebAssembly still is excelling there, which is really exciting. And this isn't just a quick aside. This isn't like a jab towards Docker or like modern containerization. They both have their pros. And in fact, Docker is working on their own like WebAssembly solution and Docker thing they're working on right now. And if you're interested in that, they have a WASM-SF talk. You can look up Docker plus WebAssembly WASM-SF, and then you'll find this talk. And it was really great. I was there for it in person. But going back to our WASM container architecture, let's see how we can actually build this out ourselves and give some quick examples of it. So let's write our first WASM and WASI application and run it on our server / container, whatever you want to call it. So I'm going to show some code. I know it's like usually might be kind of small, especially in the back, but don't worry about it. All this code is on my GitHub repo on GitHub. You can find it there. I'll probably tweet it out after this, or you can find me and ask me what the GitHub URL is. But yeah, it's there for now. And don't worry about taking pictures of the slides. That's really the main thing here. Like, it's all on GitHub. Don't worry about it. It's also for a joke because I have a picture of a slide saying not to take a picture of the slide in my slides. So I thought that was pretty funny. Anyways, so yeah, what we're going to be doing is writing our first WASI application. We're going to use assembly script because it has that TypeScript-like syntax. JavaScript's a popular language. I thought that might be good to get your feet wet. And it tends to map really well in terms of like what's going on the WebAssembly side and then what you're actually writing, which makes it a good representation, I think. So what we're really going to be doing here is just taking that WASI API I mentioned. It's mostly syscalls right now. And for example, there's one called fd_write, which allows writing to a file descriptor. And with this syscall, we can do things like, let's say, output to our console by writing to /dev/standardout. And with these WASI APIs, each language tends to have their own bindings for it. So AssemblyScript has a WASI bindings that maps from the syscall to how it happens in AssemblyScript. When really it's just calling out to the host, but that way when you import from the language, it knows what you're talking about. So cool, here's the whole application. The code's small. I'm not going to have you read this. I'll zoom in a little bit, but I just wanted to show you, like, in 40 lines, we can get our first hello world running in WASI. So first thing I want to show is, we're just importing our WASI bindings from AssemblyScript. In particular, like I mentioned, we're importing fd_write. And then we're going to have our log function. Really what's going on here, don't have to read the whole thing, don't worry about it, it's on GitHub. What we're doing is taking a string and we convert it into a binary buffer. That binary buffer is then stored into WebAssembly linear memory, and then we call that fd_write syscall. And the fd_write syscall, we're like, hey, look, here's our pointer, our index into WASM memory. Just write what's in there to this file descriptor, and then then you're writing to a file essentially. And then WASI defines their entry point as _start, so that's like our main, if you are familiar with that. And so in our entry point, we just call our log function and say, hey, hello WASI. So then if we run that, we have to compile it first. But then using the AssemblyScript compiler, we can compile our application, and we'll get like an optimized .wasm file out of that. And awesome, so cool. We have our WASM module, and like I said earlier, we kind of have to run it. So how do we run that WASM file? And here's QWOP. I like that it's just a GIF of someone trying to run, but I think it's hilarious. So what we can do is use a WASM runtime like WASMtime. WASMtime, it's maintained by Mozilla, or now the Bytecode Alliance, which is a collection of like industry folks and researchers working together to like kind of help WebAssembly grow. And it's a runtime that they're funding, or not funding, but building really. And so after we install WASMtime, we just pass the WASM module that we compiled to WASMtime, and then WASMtime's going to go ahead and run it, and we get our hello WASI. So yay, cool, we got our first WASM module. That's, about 40 lines. You can start getting started and using syscalls and things like that, which is really exciting. So cool, hello worlds are nice and all, but what if we have like some existing like big application, like, ton of code that we're like, oh man, we really just want to run this on the server, but XYZ isn't working for us. What we can do is compile it to WebAssembly, see what that's like. So in this example, we'll be looking at Quick.js, which is a JavaScript engine written by Fabrice Ballard. You may have heard of them. They also wrote FFmpeg, and I think they're the original author of QEMU. I don't know how you say it, but yeah, it's all written in C, and yeah, we'll be compiling that. So one thing that's nice is that some people already did most of the work for me, which is really cool. And what the work is really is just every once in a while you'll be using some standard library that has a, let's say, a syscall that's not correctly standardized yet in WASI, and you'll do some finagling, that's the word for it, some shenanigans for it here and there, but this is just because it's all really young. And porting is not going to be required for all applications. Your application may just work out of the box, which is really exciting. But yeah, so cool. After you have your application ready to compile to WASI by pretty much running it through your compiler that supports WebAssembly, which is like Clang, LLVM, and scripting, whatever it may be. But yeah, So we're going to go ahead and compile that. In this example, we're using WASI-env, which, like I said earlier, Clang and LLVM support WebAssembly output. I think LLVM 9 does. So that's essentially just an easy way, it like wraps around all the abstractions of installing the WASI SDK and LLVM and things of that sort. So we're going to go ahead and install WASI-env and then compile it, and then we get a quickjs.wasm. So cool, and then if we run it with WASM time, it works, and this is really exciting. So what we're doing here is we're just calling WASM time, passing the WASM file, and we say, hey, look, we have this hello world.js, can you just run this hello world.js? And then quickjs reads in the input, and then does the hello world, but from within the JavaScript engine that's compiled on a WASI. And this is a good point to show off the --dir flag. And what that's saying is like, hey, look, you have access to access this directory I'm currently in, so that --dir equals dot. That's another part of that capability security model. You know, if you try to run it without that flag, it'd say, hey, look, I can't access this directory because you did not give me explicit access to access this directory. So that's another good part of like terms of security and things that we're doing. And but wait, I have one more cool containerization server-side WASM use case. Let's say you have a library in C, Rust, or whatever it may be compiled on a WebAssembly. Maybe you're already running WebAssembly in your browser for whatever library reason, but then you decide you also want to run it in your server. And maybe that server is not Node.js, maybe it's like something like Rust. What we can do is we can take that WASM file and embed a WebAssembly runtime in your current application, and then you can start doing that code reuse and code sharing amongst your multiple applications that maybe want to run this WASM runtime. And like I said, this is really good for code portability and reuse. So what we're going to do here is this one's going to get a little confusing, but we're going to write a Rust WASM module that is then embedded into a Rust application. So we're going to use Rust, write a WASM module, compile it into WASM, and then we're going to write like just a normal Rust application that embeds a WASM runtime to run the said module we just compiled. So first we're going to write that guest module. It's about 20 lines. I know the code's maybe a little small, but there's not a lot going on here really. So by the guest, I mean the first WASM module that's going to get loaded. Really what we're doing here in this code is first we're going to import a function from the host that the host provided for us. Like we were saying, we can import functions in and give our WASM modules abilities and things like that. But we're also going to export out an add function, which is just like add A plus B, return the result. And we're also going to export a function that can then call the host function that was imported to us. That way we can kind of show off just for demonstration purposes. Like, hey, I can call out to the host and come back to what I was doing. So then we're going to go ahead and get this guest module, and we're going to compile it with WASM-Pack, which is a great tool for building Rust modules and getting it all built together and installing all the dependencies. And then after it compiles out, we have a WASM module that we can load into our host application. So now let's build that host application. Again, I'm going to zoom in on this one for sure because it's about 50 lines, and I know it's a little small, but let's highlight some key pieces here. So first thing we're going to do is we're going to go ahead and create the global store, which is kind of shared across the runtime, and then we're going to load in our WASM module, which is just that file right there, and then we're going to define that host import function, which really is just going to print out, say, hey, like I was called from WebAssembly just to show everyone what's going on here. And then we're going to create that WASM time instance that's embedded into our application and pass it in that host function saying, hey, give the WebAssembly module access to this function that I just defined. Now that we have our instance, we're going to go ahead and get the exported add function from the guest module. So like, hey, look, I want to call your add function WASM module that I just imported. And then we're going to go ahead and call that function. We're going to call add with 24, comma 24, because my name is Torch2424. And then we'll see how that works. It should be 48. And then the same process happens for the call host import function, which is like saying, hey, call into the WASM module to call that import I gave you earlier. And then, yeah. So then if we run this application, so we're just going to go ahead and say cargo run, which is going to like compile the host Rust application. And then what it's going to do is it's going to run the WebAssembly. So it does that add function that was in the original guest WASM module, give us back our answer, which was 48, which is what we expected. And then also it prints out, hey, look, like the function we called to call the host import was actually called. So cool, we can kind of do what we're saying. So that was a lot, but I'm going to start wrapping things up. They gave me a whole hour, but, you know, here we are. So, yeah, I think this is a good overview of what's going on here. So here are my key takeaways. I know I said you don't need to take pictures earlier, but if you do like taking pictures, this is probably like the next two slides are the ones to do it. But yeah, so really what I'm trying to drive here is that WebAssembly and WASM are really exciting for performance, portability, and security, especially when running your applications on the server, whether the browser or things of that sort. WASM and WASI offer a really interesting solution for sandboxed applications and containerizing them. And then WASM and WASI are really good for code reuse and portability because you can compile it to a WASM module and then run it on the browser, embed it on your server. Wherever you pretty much want to run it, it probably can do it at this point. And then here's some additional resources if you thought this was really exciting and you want to learn more. If you want to learn WebAssembly, there's WASM by example, which I wrote. Like I said, it's just a lot of bite-sized examples you can go and pull from and start learning by doing. There's also, if you're writing a language like C, Rust, AssemblyScript, even Go, they probably have a section in their docs saying like, hey, how do you get started with Go and WebAssembly? And you can kind of see it from their perspective on how they compile WebAssembly and their concepts and things. Some popular runtimes we saw was WASMtime, which is the one that we embedded and ran most of the examples in, and then Lucet, which is the one I'm just joined working with, and they're, again, the ahead-of-time compiler and also a runtime. So that's another thing to good look at. And some additional talks, if you just like talks. Patrick Hammond, they also work at Fastly, and they, I think, gave the best, like, hey, like, this is where we are with WebAssembly in 2020 right now talk, when they kind of explained how it started and, like, where it's going and things of that sort. I highly recommend that. And then also Kevin Hoffman gave a really interesting talk on WebAssembly at WASM Summit, in which they showed off their whole, like, container orchestration service that they use, where you just upload WASM files and you can, like, hot swap them to, like, pretty much like have endpoints that are just WASM modules you can hot swap, so when you call it again, it just automatically starts working, which is really exciting to see. So cool, thank you. Thank you to the conference organizers for having me. Thank you for watching, and please reach out to me here. I'll be here all day and walking around, or reach out to me on Twitter if you're watching a recording or if you just prefer Twitter. And yeah, thank you very much, and enjoy the conference. Yeah. Yeah, so I think we're doing questions too, if anyone has questions. Yeah, go for it. Yes, the question was, like, I saw that you can control the memory. I saw that you can control the memory in WebAssembly in terms of, like, how much you give it, but what about other resources such as CPU and things? That's going to be up to your runtime. I'm familiar with some of the runtimes do allow you to say, hey, like, don't let it go past, like, 50% CPU because I said so, and you'll have the same results, essentially. Yeah, and if not, it's all open source. Both of the runtimes I showed were open source, so I'm sure it wouldn't be a big thing to try to just say, hey, can I add this? I would be really doubtful if they said no. I'm pretty sure they would say yeah. So yeah, yeah, go for it. Yeah. Yeah, totally. So when I say DOM manipulation isn't there yet, what's it called? In terms of like what WebAssembly can currently do, it's essentially just passing numbers around and moving memory around. So in terms of things like DOM manipulation, the reason why it's just mostly numbers being pushed around is because they were like, hey, look, if we're going to standardize this, we need like the minimum viable product that everyone's going to ship it. So in the current state, there's a proposal called WebAssembly Interface Types, championed by Luke Wagner, and that's essentially a proposal that's going to say like, hey, look, I have this object, and you don't know what it is in memory, but if I tell you what it is, the runtime what it is, then you can start messing around with it as well. So like the idea of like, let's say a div means something in JavaScript but won't mean anything in WebAssembly, but if you can tell the runtime what a div is, then you can then start to expose that in whatever your runtime is. And this also comes into things like, let's say you want to write something in Python. The way a string is represented in Python is going to be different. So if you have this interface type in which you pretty much have a contract saying my strings are like this, so when C gets a hold of it, make sure that you give it back to me like this, then you can start to do that. So. But yeah, that's definitely in the pipeline. I don't remember the stage it's on, but yeah, it's definitely coming. And yeah, there's also a lot of good like browser manipulation, WebAssembly libraries if you want to get started today. But yeah. Yeah. So just to repeat the question too, the original question was like kind of like, hey, like DOM manipulation isn't there yet. Is there anything on the status of that? And then will there be limitations on the things that can be passed through today, or like after this proposal is landed? Which one? Today or like after both worlds? Okay. So today, it's really just whoever is implementing their runtime is terms of like what they can do. Like for example, for the AS bind thing, I essentially just go ahead and say, hey, you're passing back a pointer to something. Let me go figure out what that pointer was, and then I'll go ahead and reserve it, do the right thing in JavaScript for you. Because it's all pretty much handwritten, there's only as much support as your library or runtime is going to let you have. Tomorrow in interface types, or not tomorrow, but in the future with interface types, it's also going to be up to the language or runtime that's running it. That being said, though, once you have like a standardized way to be like, hey, look, this is how interface types are going to work everywhere, then I'm sure it'll come a lot faster than you're seeing it today. Yeah. So to repeat that again, there isn't necessarily a restriction on browser line what you can pass. As of today, I don't think so. But once interface types, maybe they don't want you to pass cookies for security reasons. I don't want to say yes or no, but I would be on the just in general, I would say yeah, you probably can pass it. So yeah. 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 Yeah, and just to repeat that statement was more about like, hey, cross-origin resources and like maybe like XSS and things, they're cracking down on that. So that's a good thing to keep in mind is that like WebAssembly will probably have the same limitations that something like JavaScript would have in terms of like fetching from wherever it wants to and exposing things it shouldn't. So yeah. Cool, there's a question over here. Mm-hmm. Yeah, I love that question. So yeah, there is a big camp. Another great talk on this. I'm sorry. Let me repeat the question. They told me to. That's why I'm like doing this whole taking a step back. But so the question was like, hey, so if WebAssembly is like this predictable, fast thing, and then it can just do whatever it wants, is there still a reason for JavaScript in the browser when you have WebAssembly nowadays? So I love that question. Ashley Williams gave a really good talk at WASM Summit this year about kind of like this idea of like where WebAssembly is headed. And we actually had a website for WASM Summit, but we didn't build in a WebAssembly. And here's the reasons why we didn't. The reason is that WebAssembly, like I said, is really good at things like image manipulation and things like that, or just heavy computation. But if you think about it, JavaScript's been around since however long it's been around, since like the 90s, and its whole goal has always been manipulating the DOM and doing view and stuff like that. So JavaScript has a lot of like built-in web APIs and things for manipulating the DOM already. So to kind of go around it and use WebAssembly anyways doesn't mean necessarily you're going to get performance benefits. I think there's going to be a place in which using JavaScript makes sense for your slower, maybe even you have like engineers that already know JavaScript and they kind of want to like do what they need to. But then WebAssembly is going to really excel at things like, okay, we want to port this whole game engine to the web and like getting those really heavy computations. So it'll be more about using the right tool for the job rather than like, oh, just this one is way better, at everything. So yeah. Yeah, feel free either. I'll go with you first and then after, yeah. Mm-hmm. Yeah. Yeah, so the original question was like, okay, cool, so you have this like fast performant thing, you're downloading it from untrusted sources, you don't know if it's been modified or not. Will there be signing services perhaps for WebAssembly, especially compared to JavaScript where you can see what's happening through just like normal analysis, whereas WebAssembly is a bytecode? On that topic, so that kind of goes back into the capabilities. So like, for example, if you were to run untrusted code on your server, maybe you're like, all right, I put it in a file system where I know it can do whatever it wants. It won't be too malicious. Something like the browser, the browser is like, hey, look, you get whatever the JavaScript gives you, and like we're not going to give you file system access, or even though the browser doesn't. But you see what I'm saying there? In terms of like actually like, yeah, I mean, yeah, JavaScript does do things maybe you shouldn't be doing. But on that topic too of signing, there's nothing stopping you from like encrypting a WebAssembly module, shipping it down, and then decrypting it wherever your host is and things like that. But mm-hmm. Yeah. So on that same topic of like people downloading things they don't know necessarily what's going on, one thing is if you look into it, Bitcoin mining actually is a big thing that happened in WebAssembly, but a lot of browsers picked up on it and they went ahead and like, hey, look, if we detect you're doing Bitcoin mining, we're just not going to run your module. That being said, it comes into like, are you including WebAssembly modules from third-party sources that you don't trust in the first place? And still, I mean, personally, the way I see it, the browser's been like an untrusted code execution environment since like browsers have happened, and WebAssembly, yeah, that's I personally, from what I've seen and what WebAssembly is currently going, with that capability, security model, the sandboxing, browsers are able to pretty much contain, see what it's doing. And from all the WebAssembly I've seen, I haven't heard of any like major like security leaks or anything that's happened yet, and it's doing pretty good in production. So, but yeah, security was definitely top of mind when they designed it. That helps. Yeah, go for it. Mm-hmm. Yeah, so the question here was like, hey, with something like JavaScript and a lot of things, we're downloading a lot of files, but we can at least see in a text format, like, we can understand what's going on here, whereas WebAssembly, since it's compiled, you can't really tell as much. In terms of like a text format and like seeing what's going on, there is actually a WebAssembly text format, so you can take a binary and it should map back to like just a Lisp-looking like language. The reason why I didn't show it off here is just because it's very Lispy, like almost looks like assembly in what you're calling things from there and there. So I think, does that answer your question? I think it did, right? I'm sorry, I like have to repeat the question. I'm like trying to remember it as I'm talking. Mm-hmm. Yeah. Mm-hmm. Yeah, so on that same topic, what the question was reiterating was, you can see what a web app manifest, for example, is calling and trying to fetch when it's running on your machine. Yeah, so as I was kind of alluding to with the WebAssembly text format, you can compile it back out, or even you could just analyze the module. And because of that capability security model, if it tries to call, let's say, like fd-write in the browser, like the browser is like, I don't have an import, I did not give you access to this fd-write, therefore you can't do it. And if you were a security researcher, let's say, you want to see what WASM modules are doing, you can totally go like byte by byte, or just do the text format and see like, okay, it's importing this function, or at least it wants this import to have access to. It wants to go ahead and try to do this loop here or there or whatever. And yeah, so I think analyzation-wise, it's like pretty solid. I've looked through a lot of WASM modules in my time, and I haven't seen anything weird yet that I was like, what's going on here, and didn't know. You know what I mean? So yeah. Cool. Any more questions? I'm more than happy to answer them. Yeah, go for it. Yeah. Mm-hmm. Mm-hmm. Yeah. Yeah. Yes. So on that topic, so the expression here was like, hey, look, like honestly, I'm just not a fan of JavaScript. I'm so excited to write things for the web in C++ and draw some things here and there, but there's not a lot of examples on it. I think that reason is I share this opinion, and so do a lot of my friends. I don't think WebAssembly is going to kill JavaScript. That being said, though, it shouldn't stop you for if you just really like C and you really want to write C for the web, then yeah, totally you should be able to. And that topic, I mentioned earlier, there's a thing called Made with WebAssembly. If you go on there, there's I think someone ported Qt to the web. So if you wanted to, you can write Qt and things, and a lot of like C code is being compiled to WebAssembly to then run on the web by using that pretty much binding with DOM and stuff. So I would check out Made with WebAssembly, the thing that I built. Just look up like C and C++, and then you can go from there, and maybe they'll find some examples or other projects that can lead you in the right way. Yeah, go, you can keep going. Huh? Oh yeah, I can show it in a little bit. Yeah, but go for it. Yeah. Yeah, I mean, so I've seen a few come out. I've been actually approached by a few people to like write a book. I just don't like writing books, but I have I have a buddy that wrote. I have two buddies. Someone wrote a game engine book in WebAssembly, which is just using Emscripten and compiling that down to WebAssembly and drawing and doing everything you need to. And another buddy of mine wrote an Emscripten WebAssembly book, which is more just like, hey, take this glob of C code, write it over here with some like hello worlds and stuff. I definitely think in terms of like the knowledge aspect of like what's out there, it's still a young technology, and there's still a lot of like tooling and ecosystem that needs to be built up. I feel like the compilers and the language are like, they're pretty solid, but now it's up to like the community to really build out all the tooling that's going to be there to really push it forward. So yeah, to answer your question, TLDR, yes, I think it would be good if there were more books because more people can get into it. So yeah. Oh yeah, go for it. To replace what? Oh, Lua? So, yeah, the question was, do you think WebAssembly will replace Lua script? I don't think it will. I don't think WebAssembly is here to like kill anything really. It's just another bytecode that can then be interpreted or run whatever. It's just really focused on security, portability, and predictable performance, especially in the browser case. In terms of Lua and WebAssembly, there's actually a lot of good Lua interpreters for WebAssembly. So if you wanted to write Lua and run it on the web browser or runtime in itself, you totally could. And yeah, I think that's another great thing about it is that, yeah. So yeah. Yeah, go for it. I'm sorry. Whoever. Yeah, you know what? Let me just try and pull it up. Let's see. I know Qt might have, yeah, we're just having fun. We're just hanging out. Made with, I don't even have my own website. I don't even visit my own website. Let's see if it's down. No, okay, that was the wrong URL. I don't think it's down, actually. With WASM, I'm trying, I just can't. WASM. Yes, all right, cool. So let's just look up graphics. That's a nice way to for me to show what's going on. We got Figma, I think, Avocode, PS PDF Kit. I know I wrote the Qt one myself. Oh, here it is. So yeah, the only one I know of as of today maybe is Qt, but I'm sure if you looked up WebAssembly graphics toolkits in C, you would find a bit more. But yeah. So for example here, I think someone just took this application that was written in Qt and then ported it over. And there's even some resources down here. So if you want to do Qt and WebAssembly, you totally can. And it's like, hey, look, you got to use Emscripten and stuff. I don't know. To be honest, I'm not a C++ expert. Yeah, so it's just but I know it exists. I've seen people do cool stuff with it on Twitter, so I'm sure you could too. But yeah. Yeah, go for it. Not entirely. So the question was hey, right now it seems like WebAssembly is more about building tooling, frameworks, and things for other developers rather than apps. I think there's definitely going to be a place for both of them. So for example, there's a lot of crypto, for example, in JavaScript, and that would be a really good use case for WebAssembly, at least in the browser. Not to there's already some web APIs, maybe not crypto, you know what I'm trying to say. But yeah, there's a bunch of stuff already on NPM that use WebAssembly as a backend. But there's also a lot of applications being built. So a good example is one off the top of my head is Figma. They're a Photoshop or a Sketch for the web. They're using WebAssembly for a lot of their rendering. So something that used to be really slow and only ran on some devices, they can now bring down to lower devices because they have WebAssembly to give them that predictable performance that they needed. So I think there's a good use case for both. And in the current state of how young it is, either you're building a tool or an application, it's helping the ecosystem because it's just one more thing people can take a look at or use for themselves. So yeah. Cool. Go for it. Yeah. Mm-hmm. Mm-hmm. Yeah. So the question / statement was like, and just a heads up, I don't work for Figma. I just like what they did there. Was like, hey, Figma, they're not really like, hey, we're a WebAssembly tool. It's more that like we're a cross-browser, cross-platform tool, and it worked really well for them. And if I'm working at a company, how can I kind of pitch my WebAssembly to my workplace to be like, hey, I think this is a good idea, something we should try. I think the best way to pitch it really is just understanding what WebAssembly is good at. So if you need code reuse, you need portability, you need to use it in multiple places, and let's say you're rewriting the same thing in C and Rust and Go for each thing, then maybe it's like, hey, look, maybe it's worth embedding a WASM runtime in our application. That way we can run it on these different platforms without having to write it 3 different times. Or another case is, I have like a Node app, and I'm doing something like parsing, let's say like a gigabyte of like, like spreadsheet data for something, and we're writing it in JavaScript because we're a Node shop. So that's another good use case of like, hey, look, we have this really intense operation we're using in Node. It's really slow. We can like save some dollars here and performance if we just rewrote a little bit of it in WebAssembly to do just that computational part, and then jump back out to Node to finish off everything else we needed. So just identifying the problem and understanding how WebAssembly can solve it, I think, would be an easy way to like submit it or pitch it to wherever you work or whoever you're talking to about it. So yeah. Any other questions? Okay, I'm sorry. Oh yeah, definitely. So the question was like, hey, do web workers and WebAssembly like work together nicely? I think they definitely do. So what web workers will do is that they'll create a separate thread, and you're able to run whatever code you need to in a separate thread. That way it won't affect the main thread in your UI, or even if you're just using like Node or something, you don't want to block the main thread. Web workers are a great solution. So throwing that WebAssembly into a web worker on top of doing that heavy operation, you could have it be long running. And a really good example of this is Squoosh, which is an application built by Surma and some other folks at Google. Surma is a friend of mine, and what that does essentially is it'll optimize images, or like let's say you want to re-encode it from like JPEG to PNG. What it does is it'll spin up a web worker, give it the WebAssembly module, and be like, hey, look, start encoding this, and that way you can still choose different formats and things on the main thread, while the web worker and WebAssembly are doing all that heavy computation without making the experience bad. So 2 thumbs up to using web workers and WebAssembly together. So yeah, great question, by the way. Thank you. Yeah, go for it. Mm-hmm. Yeah, totally. So the question was, what do you think are the 3 or the most mature tool chains right now? I personally think, well, I guess it was even covered at WASM Summit, but the most popular ones you see in like talks and things are AssemblyScript, which is the TypeScript to WebAssembly one, Emscripten, which is C++. Emscripten's been around for a while now, so it's probably the most mature in terms of like how long it's been around. And then Rust has like amazing tooling, great community behind it, and they're also building really amazing things with WebAssembly. So I would probably chop it up to AssemblyScript, Emscripten, and Rust, but Go and things are also like coming behind it really, really hot and awesome. So yeah. Any other questions? Feel free. I got nothing else going on. I'm just hanging out. Yeah. Oh yeah. Oh yeah. Thank you. Yeah. Thank you. Yeah. Totally. All right. Well, I guess with that, the talk is over. Feel free to find me after. I'm going to show off WASM Boy because David Nuwan in front keeps asking me to do that. What WASM Boy is essentially a Game Boy emulator. I'll show off so on top of that, I have I can't even spell. What am I doing? But yeah, feel free to go on if you aren't interested. But here it is. Aha, it shows off everything. But yeah, so essentially it's just a PWA that sits on top of that WebAssembly emulation library, or not WebAssembly emulation, Game Boy emulation library I wrote in WebAssembly. So this is the PWA, it just imports the WASM module, and then actually puts the Game Boy emulation to a web worker, and then runs that on the side. That way you can keep interacting and things without it. So I'm going to try to play a game with it. Yeah, and it's using, I'm really into Vaporwave, which is like a music genre, art movement thing. So yeah, there's a whole like aesthetic of it and visual appeal as like Windows and old stuff. So yeah, it's probably my favorite game to play, but it's called Tobu Girl. It's just an open source, no, it's not open source, but it's MIT licensed. It's a homebrew game made by like a game developers that really enjoy the Game Boy still. I don't have sound, but that's fine. And yeah, so really what's happening here is all the actual emulation of saying like, hey, look, I have this Game Boy ROM that gets passed into a web worker, and you have the WASM module, which is the WASM Boy library, that's also in a web worker, and it just pretty much go through, emulate the library, and pass back like, hey, here's like the image data and here's the sound data back to the main thread, and it plays it using web APIs. So all that's running in a separate thread in the web APIs, which you actually see. And then things like input, input is handled on the main thread because it's not available on the worker thread, and that gets passed back into the emulation library, which will then interact with the game. And yeah, it's just running bytes, essentially. It's like your standard game emulator. And yeah, it works really well. Yep, and you can play and have fun. Yeah, this is like kind of what really got me started in WebAssembly, was just like, hey, can I build this thing, and is it a good idea? And it turned out to be a pretty okay idea. On the topic of that as well, this is just I can't type, but another topic is I'm actually just really a JavaScript background type person, so WebAssembly was like, all right, cool, let me just figure this out. That's why I chose AssemblyScript and started getting involved there. But if you do some benchmarking of like, hey, like I wrote this thing essentially in TypeScript, what would the performance delta be between like TypeScript and the WebAssembly module? And TLDR of that, since it's AssemblyScript, you can run through the TypeScript compiler. You see about anywhere between like a 1.3x improvement to like even like 2x, depending on the device and browser you're using. It's a weird combination, but in general, WebAssembly, because of that predictable performance, is going to be faster. Not for every case, but for cases like emulating a game, it's definitely, you see some nice performance improvements, and kind of enables new applications on the web, really, is how I see it. So it's really exciting. Are you happy, Nuan? I showed off WASM Boy. Yeah. Cool. Yeah, if there's no more questions, I'll just be here hanging out, moving my laptop. But yeah, thank you very much for coming.
Check, check. Check, check, 1, 2. Mic check. Check, check, 1, 2, 2.
Hello. Okay, well, welcome to the talk on Maven Renewed. I am John Engelke, Data System Software Specialist at Jet Propulsion Laboratory. And we're using Maven for some of our software. We use it, we have a number of different languages that we use for different products. We have builds that are, multifaceted. They integrate different modules that are programmed in different languages. And we're starting to migrate more to a Maven model. And during the whole process of that, I discovered that Maven has really evolved. And so that's really what this talk is about. The evolution of Maven so that it can be used more readily with modern build systems. So Raytheon's one of our partners. I actually work at JPL through Raytheon, so we give them credit for helping. And excuse me a moment. Okay. Did that do anything? Yeah, it broke it. That's what it did. Yeah, let's try that. All right, fine. We'll just do it this way. Okay, so the premise of this talk is Maven Renewed, which begs the question, why renew something that works? Right? Maven works. It's been pretty steady state, pretty reliable for the past 15 years of its life. People are using it all the time, and it's being used in all different industries, largely for Java, but I also have used it to publish Python projects, and we did some testing. Used it for just integration testing and maybe some unit testing. There are some Maven's so extensible you can use some different plugins to actually do testing in different languages or to do deployments in different languages. And there are some competitors. I mean, there's NPM, and there's some other tooling for C++, C#. but I don't think anything really measures up to Maven in terms of its longevity and its utility. But why renew something that works? Well, let's take a look at what's going on with Maven and why renew it? The simple answer is make it work better, make it more flexible. So this talk is really about a practical solution to make Maven faster, much faster than it is. And although Maven may not seem slow if you're using it for a very long compile, and you're using it to do releases and tagging and all sorts of other things, you will notice that you're going to have multiple builds and things are going to sort of drag on sometimes when you don't want them to. And in today's fast-moving world, of course, everybody wants to have their software out quickly. They want QA to test it. They want feedback immediately. If you're a developer, you want to know if your software is working or not right away. And managers want to know that too. So this is really a practical solution to make Maven faster. It can be used to modernize the legacy installations. So if you're using the standard way of using Maven, which has been around for 10 plus years, 15 years, the life of Maven, this is going to modernize it. What I'm proposing is a relatively quick and easy implementation, which could be done almost entirely in a parent POM. It could be done simply by removing some build plugins. It could be done simply by changing some things in the POMs themselves, simple properties. And so it's relatively quick and easy. Maybe not, if you're used to the Maven paradigm, maybe not as easy as it seems. And it will definitely bring Maven into the 2020s, well, at least into the 2010s, I think. And it offers runway transparency. What do I mean by runway transparency? I mean, it's clear what software is meant for and what it is. So with this solution, SREs can say this issue came from this exact commit hash. They can tie it exactly back to the exact commit hash in the source control system. You can say this is from a developer's desktop build. Why is this out here in production? Because we all know that some developers have had to do that before. They can say, this is build X, which passed by QA on date Y. Hi, QA, why did this pass with this nasty problem? And so this is a real big help for the people who are out on the front end of finding issues with software that's running on a production service. And it's actually relatively simple. So another benefit is that continuous integration and continuous deployment systems are recognized in release tags. In release tags. Now, I'm sure people are doing this already, and I've seen it done before, but this is making Maven do it, and it's making Maven do it without its legacy way of doing things. And a lot of installations people are working on and supporting right now with Maven are actually older installations that are just sort of being maintained, right? And so nobody wants to make a giant change to a working system, right? But this change makes it worth it. That's the point. So bottom line is that every release stage actually can be identified. When your software goes to the CI/CD server, you're going to see a build number. You're going to know the commit hash from the source control system. And you're going to, of course, have a version from the developers. So everybody touches this, and we know what they touched exactly. I think at this point, I know it was marked as welcome. Thank you for joining. I think there will be. It'll be tight. You might have to stretch your legs, not be able to stretch your legs out, but I think at this point I wanted to have a brief review of CI/CD concepts and what I think is actually how this is going to benefit the whole process. What I had just done right now is I've done a quick overview of what the talk's about. Now I'm going to walk through some of these concepts, talk a little bit more about Maven, the assumption being that maybe I wanted to make sure everybody was on the same page. So, let's see, what I want to talk about is what continuous integration, continuous delivery really means, why decoupling is important, why failing fast and failing often is really important, and why people should get told if they fail. If you fail, you get a chance to fix what's wrong, and so failure is a learning experience. And traceability is another critical component of the solution here. So point of continuous integration, continuous delivery. Well, continuous integration definitely validates software works when it's combined together. As we know, developers work in silos, and software just builds and works, right? So when you put it onto a Jenkins server or some other CI server, you're basically testing whether the component which was developed separately is going to work with all the other components that were developed separately, or if the component that worked on the developer's machine because the developer had a bunch of interesting libraries installed actually still works on another machine. So that's an important aspect of CI. The code freeze aspect's important. When it gets committed and bundled and stuffed into a jar or stuffed into some other kind of package, your code's locked down. The build's locked down. As important as everything else is automating things whenever possible. So in a continuous delivery environment, you want to make sure the build works. And then you want to also make sure that you can run some integration tests against your build and that it's pushing through all the way to production because that's the idea. And it's working. Of course, it's difficult to have software that is testable only by automation, but that's a goal, to have it testable enough by automation so that a continuous delivery process can move along and push something out to production. And of course, every build is a potential release, right? So in today's world, the paradigm Maven has been working on for the past 15 years has sort of been a paradigm of snapshots and builds and tests and then releases, pushing things along the runway maybe a little more slowly. But in today's world with continuous delivery, every build is a potential release, and of course you have the eternal beta strategy. And some companies, we know some companies that do that, right? Google is a company that has the eternal beta strategy in mind. I'm pretty sure Facebook does that. I think on Tuesday nights they do their developer powwows and push their software out Wednesday mornings. And so that that's fraught with some risk, but if your CI/CD system is good enough, it catches any problems before things actually leave the system. Decoupling. Why is decoupling important? Components work independently, software and release management. So when things rely on other things to run, sometimes if that other thing doesn't run, then the thing you really need to run won't run. So we want to decouple as much as possible. A given system is not required for process completion. I can read this off. But really what we mean by that is that we want to be able to jump into the middle of a process and restart if something breaks. Keep pushing down the runway. CI/CD. Make sure that there aren't too many things that are tightly coupled together in your system chain so that, for instance, your Travis CI system won't run if another system doesn't do a build before it, or it's relying only on some kind of web service or something. Try to stop that. So minimize interdependency, coordination, and information flow. Fail fast, fail often. I find that's very important. And you want to notify people as soon as something fails so they can get on with fixing it, or prevent something worse from happening. Make sure that when you fail, you actually stop the runway from pushing or keeping pushing on down the runway. Why you want to fail is because when you iterate over problems, you fix them faster. And it isolates the cause, right? If you fail in a particular build process or area of the build, you're going to know you're failing because the CI system didn't work. You're going to know you're failing because the deployment didn't work, or this particular stage in a runway, something didn't get pushed down. And so in the world right now, we want a constant feedback from the CI/CD systems. Traceability. I think that's what this is really about. So I want to be able to say what I said earlier, which is if I'm troubleshooting a problem in production, I can go look at a list of files that were released, and I can say, oh, it came from this commit. And I can go all the way back to that commit, and I can see who did the commit, and boom, I just send it back to the developer who did it. I don't have to go start looking at version numbers and cross-correlating this or that. And so at this point in the development process, there was a failure. That's what I really mean about traceability. The build system is going to touch the software, and when the software is released, it will add the build number to it. How is traceability implemented in Maven? Well, in a whole CI/CD system set up based on Maven, there's counters, hashes, coordinates. What is a counter in this case? Well, we have an incrementation that happens during builds. Every subsequent build is one more than the last build, so there's a counter right there. Source control has hashes which are published. And Maven itself has coordinates for everything, GAV, group, artifact, and version. So this deals mainly with modifying the version component of Maven so that we can get these other mechanisms in there. All right. So release management is important. Maven's maybe one component of an entire release management system. It's a build system. You want to have a controlled release management stack so you understand what's going on. The bottom line is you want a repeatable process so that everybody, the developers, everybody throughout the whole process has a shared lexicon and they can understand what's going on. This thing built, this thing failed. We know that this came from this particular commit hash. We know that the build system failed on build number X or build number Y. Predictable outcomes. Release management needs to provide predictable outcomes. Software gets committed to source control, software gets built, software gets published, software walks down the runway, software goes to production. And we want to be able to know what our artifacts are. We want to be able to pick up our artifacts and be able to go to maybe a location where we store them and see that, hey, this is the artifact that was built on this day. There's a lot of value-added benefits in terms of helping us speed things along in terms of identifying. Sure, exactly. And so I have, I put a little drawing up here on the board, which sort of talks about where Maven is located. Again, this is sort of a review. I'm sure many people know this, but Maven sits between the developer and the CI/CD system. Also useful for publishing down to the Artifactory repositories, Nexus, Artifactory, etc. Packaging. It sits in the middle of packaging. It packages the jars up and packages things into components that can be published. Sure.
Pretty new to this world, so a lot of it's unknown, but what is an artifact?
Ah, yes, okay. So an artifact is I would say, a bundled component that is put together and published out of a build system. So for instance, if you're in Java, if you're compiling a bunch of classes, if you're compiling a bunch of Java files, they compile into classes, and they're bundled into a jar, or a Java archive. And then that can be published to a separate library, or a separate server, which serves as sort of a library to hold the artifact. So, so the jar would be the artifact, and you'd want to name it appropriately. So it would sort of be like a Dewey Decimal number, and you can go look it up again. That's an analogy. It's not exactly what we're doing, but yeah, that's what an artifact is. And that could be anything. It could be a tarball. I mean, it could be a Docker image. You know, there's many kinds of different artifacts that can be stored in modern repositories. Sure. Okay, so I'm going to talk a little bit about Maven itself, since of course this is a subject. Okay, Maven is based on POMs, a project object model. Yeah, exactly, yeah. And it's an XML file, right? I'm going to go into that in a moment, but it's based on a standard directory layout, build lifecycle. It's got dependency management for both itself, right, build plugins and project plugins, and it's extensible, which means it's not static. You can write a new plugin and make it do things, or you can modify the actual POM, the XML in there, and change the XML in such a way to make it do something a little bit different as you would like, depending upon how the plugins are written. It's XML. I said that already. And so the XML is really a descriptor of what's going on, and then the Maven application executes against the XML file, and based on what's in there, it performs a series of operations. Okay, well, I mentioned Maven's 15 years old. It's very widely used. There are 2.3 million dependencies published and used routinely in Maven Central. So there's a repository called Maven Central, which is where most Maven dependencies are stored. If you're doing anything, a lot of times you'll be grabbing a dependency of something that somebody wrote and bundled up and packaged and published to this internet archive called the Central Repository, and itself, it will need to use other dependencies that it used in building it. So when you run a Maven build, you're pulling dependencies into your local system, but those dependencies specify other dependencies that they need to run too. And so it's really a system that pulls in a number of different compiled pieces of software to allow the final build to go forward and to run. Okay, this is a snippet of a POM. And the reason why this is important is because it specifies the GAV coordinates, group, artifact, and version. Okay, and what we're going to be focusing on today here is a version. This is the basic components of a POM, which are actually necessary to label or publish something if you compile it. This is what actually gives the software its coordinates when you actually do the compile and the package. It's a standardized system. It's based on a standard directory layout. And so Maven goes and looks for things in certain places. You could customize it, but you wouldn't want to. And so the standard layout has a place for the source code, a place for resources, things like config files or static libraries that are used by the source code. I won't go into filters, but it's a directory that's used to filter objects you might want to bring in. In my experience, it hasn't been used very much. A web app folder where you're going to publish your WAR files or maybe have your HTML. It's got a whole directory hierarchy dedicated to testing, so unit tests can be built in here. This whole directory structure is integrated in common IDEs like Eclipse, IntelliJ IDEA, NetBeans. And so with plugins in those, because Maven's so ubiquitous, it just automatically picks up your source code when you load a Maven project in. Okay, now this is interesting. Maven's a stepwise product, and it's based on phases, life cycle phases. So the life cycle is really a series of steps that are executed in order to get from the beginning of a non-compiled product to a completely compiled product. And as the steps walk through, you can tell it to run to a particular life cycle phase, or you can tell it to run all the way through the entire life cycle phase. The life cycle phases include things like cleaning up the old compilation artifacts, which are sitting in a directory. Include things like deploying to a server or installing that artifact locally. What I don't think this mentions is that Maven actually has a local repository. There's a remote repository, right? That's something like Nexus or even Maven Central. Then you can publish things locally inside your organization too. You can run tests. You can only compile your product, so you skip all the other phases. Maven is, and you have the option of actually tying different operations. If you want a particular thing to happen at a certain point during the building of your product, you can modify, most plugins allow you to modify the actual configuration in the POM files so that you can tie it to a particular phase. One of those is a site plugin. I think you can tie certain aspects of it to the packaging phase, and it's actually very flexible. This is what dependency management looks like. It's what I mentioned a few minutes ago. I think I mentioned that if you bring one thing in, sometimes it can pick up different transitive dependencies and bring them in. There's a resolution procedure for dependencies. Usually, I think it prioritizes the latest dependency. That's not always the case, though, so you have to be careful what you're bringing in, and you can specify the different dependencies that you want. What's interesting about this is that in certain scenarios, you can almost, I don't know if you guys have ever heard of the deadly diamond of death. So in certain, yeah, so in certain scenarios, you can have a dependency version of that. So you can have something that's getting picked up, and maybe it's picked up erratically or sporadically, and it's causing a problem with some other piece of software that needs to have a similar dependency, and it's using that, but it can't get the previous dependency. So that takes a little troubleshooting to get past. So of course, Maven's extensible. The dependency mechanism, like I said, applies to projects and Maven itself with plugins. And these are some examples. You got a packaging through the assembly plugin. You can change how things are packaged. You can package them in tarballs or gzip tarballs. You can run scripting in the middle of your build to maybe move some things around or modify a config file a particular way based on how you set something at the command line. So for instance, there's a Groovy Maven plugin. And the release plugin is what has traditionally been used for software tagging and pushing. All right, so now we're going to get to the core of what I'm proposing here, renewing Maven so that it publishes things a little bit differently. Go back for a second. Okay, so releases. Hello. That sounded nice. Can you hear me now? So the release plugin is a de facto mechanism for tagging and publishing artifacts. What I showed you earlier was just the basic POM GAV, group, artifact, and version. Those are the coordinates used to publish everything in the standard mechanism. Release plugin's been around for a long time. It's one of 4 plugins that have evolved. I think another one's a compiler plugin, probably the deploy plugin. And the release plugin actually runs through a series of synchronous steps that execute multiple phases in Maven in order to get to the build product. Okay, so here's the problem with a standard traditional Maven installation. You're walking through a bunch of synchronous steps, which means you're repeat processing. Right, because these steps have to happen over and over again. So what happens when you do a Maven release is there's a number of things. I'll go through it in a moment. But it makes modifications to the POM to change the version. It makes modifications to a file, and then it pushes it to the source control, performs a tag and pushes that to a source control. And then once it makes that modification, well, it does a build again to make sure that modification worked. Right? And then, you know, in the middle there's a test build. There's a lot of different things going on. Yes. Yes, yes. And that's the standard paradigm with the release plugin. And that's why... let's see, if you stop... You know, I'm not sure if it does a clean in the middle between steps. It might. I think it does, actually. Yeah, so it just throws out what's there and does a complete recompile. And so that's the problem, right? Patch version changes result in a complete rebuild, which means get rid of the snapshot. And then it has to push a snapshot version later, right? So that developers can develop against a snapshot. Is this valuable? I don't think so, not anymore. Because I think development and developers have evolved enough so that we really do understand that you know, what's going on when you make a minor change, and that, you know, you can be impacting a bigger system. I think we're handling that use case with testing now in release management. Right? So if somebody makes a minor change and they push it, if your testing can't catch that, that's when you've got real big problems. Okay. So costly recompiles violate fail fast. Right? Yeah. So you might fail at the 2nd or 3rd level. Why, I don't know, but you could. Multiple recompiles over source code changes tie systems together, violating decoupling. So you're relying on picking up changes that you've just submitted, committed, get committed right to Git. You've got a big problem. It could fail in the 2nd or 3rd. Anything could happen. What I mentioned before, the semantic versioning requires multiple lookups maybe to reconnect the dots for traceability. So you get out to production, you've got something with the traditional method, and it's versioning it as 1.x.y, right? And now that's what you see there. And do you know exactly what commit that came from, what it was built from? No, you've got to go back and get into Git. You've got to check that, see maybe what changed, find out what the last commit was. There's a little bit of work there. It's nice. It's actually really nice for SREs if they can say, I know exactly what build this came from. And so you have many different operations happening during a Maven release. Consider the case of a 15-minute compile. Okay, now you've got a 45-minute compile. All right. So this is what happens with the standard methodology. The red box is the number of things that are actually happening during a Maven release process. So you've got 2 POM changes, right? So you do a release, you remove the snapshot, and you update the version, increment the version, okay? Or you remove the dash snapshot, and then you publish with that version, okay? And then you increment it again, add a snapshot, clean compile test. It's running 3 times, so you're having 3 executions of the compile phase. Ouch. Commits, right? You've got to commit the POM twice because you changed it twice. So now you're pushing stuff up to your source code system twice. That's not exactly a cheap operation. It could be, but it's not exactly. It can also trigger other things. Yes, it can. That's right. And so you've got to be, thank you. You've got to be very careful. I had that situation when I was working on a project at a place recently where we had to actually catch some of the commits and stop the triggers. It was nasty. Well, you're pushing tags too. And Maven executes multiple times. So that's an ouch. Now, the new approach is basically throwing out the release plugin. We're going to change the paradigm. We're not going to use a release plugin. We're not going to use Maven's built-in mechanism for doing releases that has been with it for 15 years. And we're going to boil it down to 1 clean compile test cycle, 1 SCM revision, and 1 Maven execution. Now that saves a lot of time. On a 15-minute compile, you're going to go down from 45 minutes plus to 15 minutes. I mean, that's really valuable. Okay, so the legacy approach is you usually run this command at the top, release prepare, release perform. So when this earlier slide here said there were 2 executions of Maven, what it meant was basically in order to get the release out the door, you have to do a prepare stage, and then you have to do a release perform execution. So you're running it twice with 2 different targets against the plugins. And so that's a problem. I think we've talked about all this, but yes, we want to make it so we can correlate the release output better with the actual inputs. Okay, so CI-friendly Maven. So goodbye release plugin. I'm going to remove it from all the POMs. Just wipe it out. No more release plugin. We're done. And we're introducing a concept of flexible versioning properties, which are bug-free and stable since Maven 3.6.3. Now, they were introduced in 3.5, but 3.5 had some problems with dependency resolution. And the place I last worked at, I worked there for a number of years, there was an idea that it was a very regulated environment. There was an idea that you could actually separate the code into tiny little modules, and so then make fixes in those tiny little modules, and then testing could just approve a tiny little module and say the whole product works. But it doesn't actually work that way. You know, if especially in a regulated environment, maybe you change a tiny little piece, right? So you've got maybe we had 80 modules. So 80 dependencies for a product we were building going out the door. So 1/80th changes, QA or the regulators, they still want to check the whole thing completely over again end to end. They don't care if that tiny little piece changed. They're their whole, and especially, I mean, it's a good idea, but when you get to very low level in the product, something that affects everything, like maybe a library that controls JSON processing, for instance, or some kind of monetary calculations. You change something in there, and it can definitely cascade through the whole product. So unit testing only goes so far. Contrast that with some place like Google, which I heard a few years ago, really had just one repository. We had, 80 modules in 80 different repositories.
They call it a mono repository, I think.
Yeah.
Everything has the same Git hash.
Right. So, let's see, would this work there? This might not work so well there. But maybe it would, right? Because you could tell when something broke because it would be that hash and you could see what changed. So 3.6.3 is the way to go. It's actually the latest Maven, and it doesn't have the dependency resolution issues where it would lock up. And it includes three properties that it is allowing to go into the version: revision, SHA-1, and change list. Okay, so you do this, and you're modifying your version property, and now you have to use something called the Maven Flatten plugin, so that when you publish this to an artifact, a jar, that the Flatten plugin makes sure that the snippets of the POM actually have the properties fleshed out inside that snippet of the POM that goes into your jar when it's published. And in order to publish it to source control management in terms of tagging, you have to do a minor change to the SCM plugin to make sure that it picks everything up the way you want. All right, so here's an example, actually, of the change. So remember, the release plugin's gone at this point. So how we deal with that is we're adding new properties in. But not only are we adding new properties in, but we're defaulting them to certain fixed values. And we're doing it this way so that we can actually see what happens when we do the build, right? So we can see what happens depending on how we set up the build, right? So with these default values, for instance, for the revision, 0, right? So a revision of 0, revision is really correlating to a build number in something like Jenkins. But if a developer is running it on their own machine, they don't have a build number, it's always going to be build 0. The SHA-1 hash, if someone, that has to be calculated and that property has to be inserted. If someone doesn't insert that, it's a key that it maybe wasn't built in a build server, but it gives us, more importantly, it gives us a placeholder to actually insert that, right? And the change list defaults to snapshot, so whenever a developer builds, it's build 0 snapshot. So you... Is
the SHA-1 equivalent to the Git hash?
Yes, exactly. But it's not filled out automatically. This is a property, right? So we have to fill that out. We have to calculate the Git hash. And now the good part, the great part, is that these kinds of things are already available in the CI/CD servers, right? So we're good. We can grab the variables from the servers and we can put them there. So if you look at the version number, 1.0.0b revision, in this case it will be 0. SHA-1, okay, it's empty. And then change list is dash snapshot. So you're going to end up getting an actual build from this that is reflective of what Maven was doing by default previously, but with a build number added, which is a key, build 0, that it was built on a workstation. I mean, somebody could always fake it and do something, right? But it's unlikely.
Well, it didn't have to get checked in to get that way, and therefore it'd be traceable what they did. Otherwise, the build server wouldn't see what they did.
Well, yes, they could do that, right? That's one mechanism of doing that. But you can also replace these in the command line, so that's the key here. So if they do it in the command line, yeah, you know. But anyway.
Or they could put their artifact in the artifact repository.
Yep. when you get into the realm of guessing how people are hacking things, there's a million ways they can do it. Just rely on people at some point to do the right thing. Now, another really interesting part of this, I don't think this shows the mouse, does it? Oh, it does. Is right here. See, I have the version here. So this is a semantic version. So what was happening before is the release plugin was actually controlling the semantic version, but only partially controlling it, right? So you got major, minor, patch. So it was controlling the patch version. Right now, developers would set major and minor. This kind of changes that, and I think it changes it in a good way, because it actually puts the onus of managing the semantic version on the developers, and they really should be the ones who are doing that. Now, if they came in and changed a POM file, and there was a spelling error, it said Jet Propulsion Laboratory, and they changed that to an R. I don't think that really counts, as something that should be counted as even a patch version, So we're kind of moving forward here with the whole conceptualization of what it means to be a developer and the responsibilities of managing your software. You're a developer, you make a major change, you make a breaking change that breaks the interface down below it. Okay, change either the major version or the minor version. If you do a minor fix, like change the character that was asked in a bug report, a character in some text, okay, make it a patch version, change. But now it's up to the developer to do that, and they can make that decision. Now we can see that things change because we will know that the hash changed, and we'll know that the build changed, right? And we'll know that it won't have a snapshot. So let me keep going here. So, okay, so we do all this, right? And we've got this whole system set up. This is a second component of it. We have to add the flatten plugin to our parent POM, or maybe to our main, our project POM. The reason we want to do this is so that when we publish things, right? So previously Maven was taking care of commits and pushing and changing the POM. And if you take a look at the version, if I go back here, the version didn't have these property placeholders in it. So the flatten plugin is what takes care of that. Takes care of fleshing it out to complete text rather than leaving property placeholders in something that mean nothing when they're published inside of a jar. Okay, then you've got the source control management plugin, and you want to be sure you modify your tag so that your tag version reflects properly on what your project version is. Now, I think there's a glitch in here. I don't think project version is what I wanted. I think what I wanted to do is I actually wanted to flesh it out with something more like this right here, so that you would actually put the version. It would pick up those placeholders that are appropriate for that particular build. But that allows you to tag, and your tag, you would run the SCM tagging operation separately now. Rather than relying on the release plugin, you're going to run multiple steps, right? But releasing is really only one major execution of Maven with the compiles and stuff. The tagging is, you can do this in the same command. I guess it could be considered an extra execution, but yes, I would. Yes. Right. Okay, so I'm just going to go through putting it together here. So the release implementation, build versioning is controlled with the Maven property injection, right? So when you execute Maven, you're going to put the -D flag. Property name is equal to something, right? And what I had mentioned earlier, the keys to the development build are these values being in the actual artifact name. And so you set it up in your CI/CD system in Jenkins. So when you execute Maven in Jenkins, you actually put the correct properties in there with the actual values, the actual properties that are provided by the build system to fill it out. Exactly. Yeah. So that's the key here, right? And it's actually pretty cool because it gets rid of all the overhead of publishing. So again, everything's going through a single phase rather than multiple phases. Yes. Yep. I'd have to think of an example. There is an example where it would fail on the second or third build. I've seen it happen. But yeah, right. There's something happens. But yes, it's exactly the idea. Complete traceability. So you can retrieve the exact build from the CI/CD server, so you can see in your list of builds what build it actually was, where the problem happened, or where something in production came from. And you can tie back the exact source code commit, which is what I've been hammering at this entire, which correlates, tags, everything. And developers control semantic versioning. You're no longer subject to, the actual release process specifying your semantic versioning by just changing an ancillary release file. That doesn't have anything to do with your software, right? Change a POM, that doesn't change your software. So why should a patch version change? Because you can simply not change any source code, and you can run the release plugin 2 or 3 times, and you've got patch version changes. It doesn't make any sense. So I think this mechanism makes a lot more sense. Okay, so this sort of gives you an example of what it would look like. If a developer, and I used an open source jar library, Jetty, to show you what it would actually look like. So if your semantic version was this, and you're building on a development workstation, it fills in the 0 and it adds a snapshot. So you would get this jar right here with this naming convention in your local repo. Or if somebody pushed it up to the the artifact repository, it would look like this. The server would do things a little bit differently, right? So it's going to start including the build number and the SHA number. You can specify it. So if you got build 1170 and your SHA is this, you're going to end up with this jar name. So for the same jar in a release scenario, 9.4.18, build 1170, boom, you know what happened here in this build for this project right here inside your CI/CD server, and you know the exact commit. And this is what would get pushed out to production. So you'd actually be able to look at this in a production environment and say, oh, wow, okay, I know where this came from right here. I know the build that produced this. Why is this having problems? We know the build. Let's go look at the build. And we know the code was at this particular exact stage. Okay, so semantic version is more of a concept than it is. So semantic version is embedded in the Maven version, to answer your question. And so the Maven version becomes a longer string instead of just having like major, minor patch. You got major, minor patch plus build number plus change list plus SHA, right? And so version, I guess I'm using version for two different things here, but that's why I'm saying semantic version versus version.
Okay, yeah, I think the only reason why I asked, I think I'm struggling a bit. So like if you use this semantic version, you deploy your dependency into Artifactory or Nexus or wherever you're storing your artifacts using that semantic version, and you have another like in-house dependency that I guess depends on that. Like how do you reference? If that makes sense. So like if I deploy some version, some snapshot
Okay, it makes sense. Yeah. So you're going to refer if you're referring to a particular. Oops, let me go back. Referring to a particular jar, you're going to use the entire version number here when you're doing the dependency specification. So it's going to go look for this. It's capable of actually you're going to know what you need to use, right?
In a highly regulated environment, yeah.
So you can go pick out a particular build and build against that. Hopefully the CI/CD server is publishing Java doc. So if somebody actually needs to upgrade a version, I guess the paradigm now is why would you, if feature or functionality in the interface of the product, you would actually go and seek out that product, but maybe not necessarily upgrade it if it didn't need to be upgraded. Make sense? Sort of. What's that?
I think, were you asking about dependencies? If you're writing something that depends on this, then every time this changes, you have to go and change your dependency.
Yes, yeah, that's right. So, but look, because the developers are controlling the semantic version, you're going to be able to pick this build out, right? I'm assuming that it's not going to build. It might build if somebody hits the build button, right, and forces a release. But generally, it's not going to build. I mean, you're not going to need to update it unless the developer is cognizant enough to make changes and then upgrade the semantic version, because nothing really changed unless the version changed, right? So you would be able to go get any one of these builds, and there hopefully would be only one. Right. Okay. So these are the commands. These commands on a local developer workstation would actually create a snapshot build. It's a pretty concise command right there. Developers also own snapshot deployment. You can deploy a particular snapshot. So I wouldn't I have an error here. I wouldn't change the revision here if I'm deploying a snapshot. I would add the SHA from a developer machine. Release engineers own releases and configure CI/CD servers to tie builds to commit hash. So that command would look something like this. You set change list to nothing. So then you get this with build. We're assuming build 377 came out of the CI/CD server, and the hash is added, right? Because here we're setting the hash. And the build number is being picked up from the CI/CD server. This is what happens if you... I wonder if that got duplicated. It might have. But this is what that looks like. Let's see. Okay. So for a minute, I'm going to talk about the pipeline implementation. So the server, CI/CD server tags and pushes the build artifact to a repository. In this case, when you actually publish something, a webhook, or possibly, can be sent to a subsequent process kicked off to keep pushing that down the pipeline. And when you send that webhook over, you can send it the name of the artifact that you just published. And as things flow down the runway, the software is completely traceable. Okay, so build times reduced. This is the benefit. Build times reduced. People oftentimes talk about Maven versus Gradle. Well, if you can make Maven this fast, Gradle has a big learning curve, especially those eternal beta guys. They went with Google. They went with Gradle for their Android development. But maybe they didn't need to if Maven was running this fast. And so this makes Maven, where people oftentimes talk about it being slower and less agile, it makes it into something that's a lot faster and a lot more agile and a lot more flexible, and it can be used going forward into the future, and that was the point of this. I have some references here and questions, and we already answered one. But I can try to clarify that more if you're interested, if you want to come up after. But yeah, the coordinates, you would know exactly what you want based on the entire, let's call it the Maven version, rather than just relying on a semantic version, because that's what's going to end up getting published. Yeah. Any other questions? I would have been happy to do a demo during this, but unfortunately, passing that through a review process is not as easy. They want to look at every slide and everything you're doing, and for good reason, right? So, okay, well, thank you very much. What's that?